Good morning, my dear JEE 2026 warriors. This is your Captain Shreyas. Welcome to the PWJ English channel. And today we are going to do the most important, most expected, most likely, most favorite questions for this year of 2026 based on the previous year analysis and also the mindset of IIT Roorkee. Some of them are really good questions. Some of them are based on very old PYQs of IIT Roorkee, and of course, some new questions which you are going to love to solve. I hope I'm audible and visible to all of you. Let me know quickly in the chat box. Rakesh, Kushal, Sivakumar, everyone, Black Mastery, yes, Nijay, Akhil, everyone. Let me know quickly in the chat box if I'm audible, visible to all of you. Yep. Okay, so let's begin. There are some really killer questions and I'm not expecting you to solve before me or anything. I'm just more interested that you should understand the concept, you should understand the explanation, you should appreciate the idea behind the problem. You should be able to solve a similar idea based question in the real examination. And this will also give an idea and a direction on which type of questions you should be solving in the next few days, just 2 weeks barely. All right, so I hope you are alert with some pencil, with some paper in case you want to scribble something, and make sure your focus is completely on the screen. Okay, smash the like button in case you haven't done that, and subscribe to the channel right away right now so that you do not miss any other classes. I'll be conducting more classes only if you like, only if you comment, guys. That's very important. I need that motivation from you. Here is the first question coming up on your screen. Ready for it? Okay, great. I'm clear, Akhil. Okay. We'll talk about priors later on. Sivakumar, explain the mock test set by maybe later on. First, let's focus, Sivakumar, on the questions ahead of us. The work done by the force A y square I cap plus 2x square j cap, where A is a constant, x and y are in meters in the path shown. I think this should have been like this way. Is how much? Okay. Now, similar question was also asked by IIT Kanpur long time back, but it was slightly easier. This is a slightly more complex question, and we will see how to solve this. So what is happening is you're starting from here, going here, and this arrow mark is also wrong. 1 second. Okay. So you're starting from here, going like this, going like this, going like this, and coming back over here. So in this closed path, what is the work done? Now, the most common mistake which kids do is, because you're coming back to the same point, many people think the answer should be 0. But remember, that is only true if it is the conservative force. This doesn't even look like a conservative force, because you can see the I cap direction has y coordinate, the j cap direction has x coordinate. So definitely it will not be conservative. Most likely the answer won't be 0. If by chance it comes as 0, that's a different story. But otherwise, it doesn't seem like 0. So common mistake is marking 0 as an option, which is definitely not correct. Okay. So how do we exactly do this? First of all, let me write down the force over here. The force which we have is a y square I cap is a y square I cap plus a 2x square j cap, or 2ax square j cap, 2ax square j cap. I'm going to go around like this once, right? I'm going to go around like this once. So I'll just show a square randomly over here. I'll just show the direction in which I'm going to go. That's all. Okay, now let's start. The first thing that I'm going to do is try to get a generic expression of the work done irrespective of which direction I am going. Let's try to get a very generic expression. So if I try to calculate the small amount of work done for a small displacement, it will be nothing but f bar dot displacement. That f bar already we know is ay square I cap plus 2ax square j cap, and the small displacement that I do in 2 dimension will be dx I cap plus dy j cap. So think about it. If I undergo any kind of small displacement ds bar, it will be something in x, something in y. So this will be dx, this will be dy. So dx I cap plus dy j cap will be the vector form of any random displacement in any random direction. Now, if you do the dot product using simple rules, you will get the generic expression. Look at it. I cap will multiply with I cap. So this will be nothing but a y square into dx. This will multiply with this. So this will be nothing but 2ax square, 2ax square multiplied by dy. Everybody following till here? Give me a thumbs up right away, right now. Okay. Well, we'll see whether the answer is right or not, Venkat. Whether you have whatever you have mentioned, whether it is a D option or not, we'll figure it out. Okay, once we get this, let's find it out for every single part from here to here, here to here, here to here, and here to here. I know the coordinates already, so it's okay. So first, let's go like this. And in that case, the work done in the first part will be integration of this quantity from here to here. So it will be nothing but integral of this quantity, which is a y square dx, plus 2x plus integral of 2a plus integral of 2ax square dy, 2ax square dy. This is going to repeat for all the things, guys. This is going to repeat for literally everything. Okay. Now, if you observe carefully, from here to here, when I go from here to here, okay, when I'm just going horizontally, you will notice one thing. In this scenario, I am not changing my y coordinate, so my dy will be a big fat 0. Is that very clear? Because I'm just going parallel to the x-axis. I'm not changing my y coordinate at all. So obviously, my dy, change in the y coordinate, will be 0. That means this entire term will be a big fat 0. Gone. Now, if you switch over here, in this journey, my y coordinate is 0 because I'm moving on the x-axis. So my y coordinate itself is 0. So naturally, anything into 0 is 0. So even this is going to be 0. So I noticed the work done in the first part from here to here is going to be 0. Is this clear? So out of that entire quadrilateral, the first segment has come out to be 0. Everybody gets this? Okay, perfect. Now let's go to the next part. Let's go from here to here. Let's go from here to here. So when I'm going like this, then the work done in that second segment, again, same integration, a y square. Now notice what y coordinate will be. Well, y coordinate is changing. Okay, so y coordinate is changing, and dx, well, I don't think dx is changing. We'll keep in mind. Anyways, so 2ax square dy. So in this segment, my x coordinate is not changing. So that means dx is 0. That means this entire part is going to be 0. Everybody clear till this point? In this part, my x coordinate is constant, so dx has to be 0. So 0 into any number will be 0, even their integration. Now if you focus over here, because in this segment, my x coordinate remains constant, rather it becomes d. This is exactly d. So x is actually constant and it is equal to d. So d, a and 2 are constants. So 2a and d, I can bring it outside the integral. Only thing that remains is integration of dy. My y coordinate keeps changing, so integral of dy remains. And if you notice, the y coordinate starts from this number 0 and it eventually goes till d. So the limits of this integration will start from 0 and go till d. So if you do the math, it will be nothing but 2ad, this was d square, sorry, because x was d, so this was d square. Okay, multiplied by integration of dy is y from the limits d to 0, so d minus 0. So hence this will be nothing but 2ad cube. Is this clear, my dear warriors? Everybody till this point? Very good. Okay, now 2 parts done, 2 more to go. So that's what I'm saying. IIT questions, even though it is single correct, double, multiple correct, whatever, it might be on a singular concept sometimes, but it could be lengthy. So you have to have that patience. Any step you make a small mistake, you are going to mess up the calculations. All right. Now let's go to the second and second is done, third and fourth part, and let's see what do we really get. So let's start going from here to here, guys. Let's start going from here to here and see what is the work done in that third segment. What is the work done in that particular third segment? Very similar expression. I'm just using this thing over here, ay square dx. So just using that, W3 will be integration of ay square dx. This was the generic expression, plus 2ax square dy plus 2ax square integration dy, right? Same thing what we have done here or here, same thing. Now in this segment, tell me what might be 0, what might be constant, etc. When I am going from here to here, as you can notice, my y coordinate is not changing. So this is going to be 0. So this term vanishes. So this is going to be obviously 0. In this entire segment, my y coordinate happens to be always a d. Keep this in mind. This is your y axis. This is your x axis. Keep this in mind. So my y coordinate always happens to be d. So this is basically d, and my x coordinate keeps on changing. So therefore, I can say this W3 will be, a is the constant, d is the constant, y square I will put it as d square, integral of dx, but there is a small catch, and this is a second pain point of many kids. They will make a mistake here. Yeah, be careful. Many kids are going to put the integration limits as 0 to d. That will give a wrong answer, because I am not going from 0 to d, rather I am going from d to 0. Check the arrow mark. So be careful when you substitute the limits. This will be d to 0, my dear kids. So this will be ad square 0 minus d, which is nothing but minus ad cube. Minus ad cube. Got it? Common mistake. Many kids are going to make this. Alright. Now, next important thing is the fourth part, fourth segment. Let's go down like this. Let's go down like this. So let's understand what is really happening in this segment. This is the work number 4 in the fourth part. So my dear warriors, in this segment, can you see my x coordinate? This is my x axis, right? So my x coordinate is 0. X coordinate is 0. All right. So let's substitute first of all our generic form, which I had already mentioned, the same thing. So it will be nothing but integral a y square dx plus 2 integral a x square dy. So in this segment, x coordinate is 0. So this entire term is going to vanish. So it is going to become 0. In this part, even the x coordinate is not changing at all. So dx will be again 0. So again, this will vanish. So therefore, W4 will be 0. W4 will be 0. So once we are done with all the 4 segments, it's time to sum them up, because work is a scalar quantity. We can just add the numbers with the signs. No need of vector addition. So if I want to find the total work done, let's calculate. This is 0 in the first case. W1 is 0. W1 is 0 plus W2 is 2AD cube. W2 is 2AD cube. W3 is minus AD cube. It is nothing but minus AD cube. And W4 was just 0. So it was just 0. So therefore, the total work done, 2 minus 1 is 1. So it will just be AD cube, guys. And out of all these options, I think option C should be right. And let's see whether it is right or wrong. Let's just go to the answer slide. It is AD cube. Got it? Yeah. So many kids make a mistake either in the calculation, or they make a mistake initially. They take it as conservative force and write it as 0, which is obviously wrong. Third common mistake in this is putting the limits especially in this third segment where you had to put it from D to 0. If you don't, you will not get negative sign, you will get positive sign. Then your answer is completely different. Okay. And also keeping a track of the calculations when what is 0. Else you might get some non-zero quantities which will again mess up your answer. I hope you loved this question. Yeah, everybody loved this question. Everybody understood the concept. Always, whenever you get such relationships, whether it is in X or Y or Z, Y square, whether it is with I cap or not, doesn't matter. Always ensure that you find a generic expression like I did over here. So this is the crux of the problem, the initial stage of the problem, and this base is used for multiple parts. This part, this part, this part, this part, anywhere. It could be anything else. W1 alone, can you say how the dx thing is 0? In the first work, what is happening? I'm not saying dx is 0. No, I said dy is 0, man. I said dy is 0. I never said dx is 0. dy is 0. See, from here to here, my y coordinate is not changing, x is changing. So that's why change in the y coordinate is 0. But I said the y coordinate itself is 0 because you are moving on the x axis. So this quantity was 0. Is that making sense? Akhil, V? Yeah. Yes, this is the JEE Advanced level question. Okay. Moving on to the next question. This was asked in 2019, but I feel this is a must solve. I'll tell you why I'm making you solve this. This kind of similar questions have come even before. There was a sphere, there was an arc, and from that arc some part is missing and they have asked what is the potential or field. Or sometimes there is a sphere, there is a hole, what is the field inside, what is the field outside. So these models have repeated multiple times, and this also came by Roorkee, and Roorkee loves this kind of questions where they always try to ask the field or the potential due to multiple charges arrangement or sometimes due to gravitational field. So that is why this question becomes very crucial. Okay. Okay, Kushal, I think you understood that part now, finally. Great. All right. Yeah, so the y coordinate was 0 and change in y coordinate was 0 in W1. There is a thin spherical insulating shell. Insulating shell, keep that in mind. That means the charges, whatever it is, it will remain on it. It won't be able to redistribute itself. That's the difference between a conducting shell and an insulating shell of radius r carries a uniform distribution of charge such that the potential at its surface is V0. A hole is drilled and made on the shell without affecting the rest of the shell. Which of the following is correct? So you have a shell, you have made a small hole on it, and because of that, you know, the whole field, the potential, all these numbers are going to change. And that is exactly the options if you notice. First option says the ratio of the potential at the center to that at a point somewhere r by 2 from the center. The potential at the center, how much will it change? The magnitude of the field at the center, the magnitude of the field at some point which is at a distance of 2r from the center. So I can see 3 points over here. One is the central point of the sphere. Second point is at a distance of r by 2. Where is it? Yes, at a distance of r by 2, potential is asked, and the third point is at a distance of 3r. So these are the 3 points which we might have to figure out the field potential. Alright, so let's draw the diagram. I don't need the options now. I just know there are 3 points and I have to compare the fields and potential. So I've just drawn the diagram for you. I'll just create a duplicate. Let's start one by one. Okay, now see, because it's an insulating shell, charges can't redistribute. So if you take out a small chunk of it, small chunk from the shell, small amount of charge is lost. Now let's figure out how much exactly is that charge which is being lost. So earlier on that entire shell, the charge was, let's say, Q. So what will be the charge per unit area? Charge per unit area. It will be nothing but the total charge divided by 4 pi. I think the sphere radius is r, so 4 pi r square. So whatever I am taking out might have a charge of dq. This is what is taken out of it. So that dq, that dq will be how much ever charge you have per unit area multiplied by the area which you have removed, multiplied by the area which you have removed. The charge per unit area is obviously q divided by 4 pi r square right from here, multiplied by the area which you have removed. The small area alpha is much smaller than 1. That means it might be 0.00000056 like that, 4 pi r square. So it's a very small fraction. It's like a fractional part of it. So it will be alpha into 4 pi r square. So as you can notice, 4 pi r square is getting cancelled. So it is just alpha into q. So this tells me alpha is nothing but the fraction of the charge which has been removed from the entire sphere. That's the first understanding which we got. Okay, everyone, great. Now let's see what do we do next. We have to figure out the potential at the center and at r by 2. This is the first thing. So let's concentrate on the potential part. And over here it was mentioned that the potential initially was V naught due to charge Q. So initially the potential was V naught because it was carrying some uniformly distributed charge. So that V naught will be Coulomb constant into Q divided by R. This is all initial before even removing the charge. Now let's concentrate what will happen at the center. The potential at the center will be, first, if the entire charge was there, how much ever that potential will be, minus, because I have removed, minus whatever charge has been removed from here. Due to that, how much ever potential would be there. So hence, that Vc will be V naught minus that dV, which is going to come because of that removed charge. So the potential will reduce from the total potential because this has been taken out. Okay, so how much will this be? This V naught is nothing but kq divided by r. How much is this potential dV? Guys, this charge which you have taken out, yes, it is slightly spherical, but because it is so small, it looks like a point charge. So the next idea is this dq is going to behave like a point charge because it is very small. And from the point charge, you are at a distance of r. You are at a distance of r from it. So hence, that would be k into dq divided by r. Okay. So therefore, this Vc will be kq by r minus k dq. What is dq? dq, we figured it out. It was alpha into q. So just write it as alpha into q divided by r. So it will be kq by r into 1 minus alpha, but kq by r is nothing but V naught. So Vc will be nothing but V naught into 1 minus alpha. That is the first step of the problem. So we saw center, the potential is V naught 1 minus alpha. So I can see one of the options, at least the potential at the center is reduced by 2 alpha V naught. No, yes, as you can see, potential at the center, it has reduced by alpha times of V naught. It has reduced by alpha times of V naught because this is nothing but V naught minus alpha V naught. V naught minus alpha V naught. So it is not 2 times of alpha V naught. So hence the third option is obviously, sorry, not third option, the second option. The second option is obviously wrong. 2 alpha V naught doesn't make sense. Correct? So this is obviously wrong. Now what about this? Potential at the center we figured out. What about the potential at r by 2? I think that also we can figure it out. It's not a big deal at all. So how do we find the potential at the distance of r by 2? At a distance of r by 2. Come on guys. This is that point which I'm talking about. This is at a distance of basically r by 2. Naturally, even this distance will also be r by 2. Okay. So the potential at this particular point, if I call it number 1, is the entire sphere's potential minus the potential due to dq charge at r by 2. At r by 2. Inside a sphere, no matter where you are, the potential is constant. Do you remember that? So some students think, sir, if I shift my location, the potential due to the entire sphere will change. Wrong, it will still remain the same. So this is still coming out as V naught since the potential is same everywhere. Everywhere. Potential is same everywhere whenever you are inside. Whenever you are inside. That is why it is V naught. So all these concepts are necessary. Else you keep thinking, what should be the potential due to the entire sphere at some random location? How many of you remember this concept? Yeah? Okay, perfect. All right. Now, this is V naught minus potential due to this guy over here. That will be nothing but K dq, but this time the distance will be R by 2. Think of it like a point charge and you are trying to figure out the potential at a distance of R by 2. Okay, so this will be V naught. This 2 will go on the top and yeah, 2 will be there, K will be there, divided by R will be also there. And what about this dq? We saw that this dq is nothing but alpha q. So this is nothing but alpha into q. Now that's it guys. Kq by R is V naught. So therefore this will be 2 alpha and into V naught. So hence this will be V naught common 1 minus 2 alpha. That is the potential at this distance. And right now I can see the option says the ratio of the potential was asked. So if the ratio of the potential was asked, that means we have to figure out what is the potential at the center by potential at that point. At center it was V naught 1 minus alpha. So it was V naught 1 minus alpha. At this point it was V naught 1 minus 2 alpha. So V naught will cancel. So 1 minus alpha by 1 minus 2 alpha is the answer. So 1 minus alpha by 1 minus 2 alpha is the answer. I can see exactly what I wanted. So first option is correct, second option is wrong. Cool? Everybody? Awesome. But that's not the end of it. Now the third and fourth option. The third option says the electric field at the center. Fourth option says the electric field at a distance of 2r. So electric field concept is there. Okay, you have to figure out electric field at the center versus at a distance of 2r. Okay, now there are some nice things over here. Let's first talk about the center. This is the center. Now if the entire shell was there, the field would be 0. If the entire shell without this being taken out was there, then the field will be 0 obviously. So if I take out this particular charge out of it, then the field, then the electric field at the center will be only the field due to dq, since due to shell anyways inside is 0. Electric field, not potential, don't get confused. Electric field is 0, potential is constant. So in the previous thing V naught was same everywhere, but when we talk about the field was 0. So the contribution due to the shell was never there as a total, but only due to the removed charge the field will be there. And this is now like again a point charge guys. This is nothing but a point charge of course. So it will be nothing but K dq divided by r square. But we know what dq is. dq is alpha q. So let's just substitute that. So it will be K by r square alpha q. And what I'm going to do, I will take r outside. I will write kq by r over here and then I'll put alpha. R into r is r square, alpha q, k is there on the numerator. Why I did this is deliberately because I know kq by r is V naught guys. So that's why this will be V naught alpha divided by r. So that is the electric field at the center. So how much has the electric field changed at the center? Now the final one is V naught alpha by r. Earlier when this was not removed, it would be big fat 0. So hence the change will be V naught alpha divided by r. Earlier this was old when due to entire shell, obviously it has to be 0 everywhere. So the change is V naught alpha by r. So let's check it out. Let's check it out. The magnitude of the field at the center has changed by alpha V naught by 2r. No guys, this is wrong. This is definitely wrong. That number 2 should not have been there. Yes, it should just have been number 1 or just alpha V naught by r. Yep, everyone? Okay, okay. Yes, Sonali, my switch keeps turning on, off, toggle switch. Yes, sir. What to do? Okay. Now, the last point over here was the field at a distance of 2r from the center. 2r from the center, guys. So, let's go out of this entire thing. This charge was q. The removed charge was dq. Okay. And I am going at a distance of, this is r and this is r, at this particular point, trying to find the field. This is point number 2. So the electric field at point 2, think about it, will be the contribution of two things. One, due to the entire shell, minus negated from the charge which has been removed. So if the entire shell was there, there will be some field. From that field, negate the field contribution of only this small charge. So it will be nothing but field due to the shell minus the field due to the point charge removed. The point charge which has been removed. This is truncated. So what is the field due to the entire shell? It will be kq divided by what is the distance? It is 2r. Be careful. From the center. Yes, outside the field is going to behave as if the entire shell's charge is concentrated at the center, and from the center you calculate the distance, which is nothing but 2r. Okay. Minus the field due to the point charge. Think about it. It will be nothing but k into dq divided by r square. Okay. So this will be kq divided by 4r square minus k by r square. What is this dq? We just saw it. dq is alpha q. So that has helped us in every single step. Alpha q over here. So this will be kq by r. This 1 by r is again there. And then we have 1 by 4 minus alpha. Just check this out. 1 by 4 minus alpha. What is this number? kq by r. kq by r is nothing but v naught, guys. So this is nothing but v naught divided by r, and we have 1 by 4 minus alpha. Yes, everyone? Awesome. So if you notice the reduction delta E2, the change which has happened is because of this extra term which has come. This has caused that reduction, and that reduction is nothing but alpha v naught by r. Just check this out. Alpha v naught by r. Alpha v naught by r is the one which is causing that reduction. Let's check the options now. Let's check the options. Where is it? The field at the center field at a point located at a distance of 2r will be reduced by alpha v naught by 2r. No, guys. It is just alpha v naught by r. No, number 2 should be there. So both these options get out, eliminated. So it has reduced by alpha v naught by r. So how much has it been subtracted by? So it is wrong. Everyone? Yeah? Let's check it out. Yes, only the first option is correct. 2, 3, 4 is wrong. 2, 3, 4 is wrong. So this is how you should be solving the questions, my dear warriors. Are you enjoying the questions? Have you smashed the like button? Show your enthusiasm when you like a question, when you love such things. It shows you're progressing. If you don't love these questions, guys, then JEE Advanced will feel difficult. You should enjoy the questions. You should see the hidden things. You should see the concept behind it. This question had so many things about conductors and fields and potentials, inside, outside. How do you calculate those things when masses, charges are removed versus superimposition? Yeah, it's crazy. Sir, it is, no, 3 by 4 will not come. I'll tell you why. Because this number alpha is there. See, alpha is there. This is not having alpha. So don't do minus 3 by 4. Guys, be careful. Alpha is there. Okay, so you cannot write 1 by 4 minus 1 is minus 3 by 4. Okay, Kushal, is that fine? Yeah, so be careful. So if you look at only the difference, the change in the field, not the electric field itself. The reduction is delta, which is only alpha V naught by R. So I hope it makes sense. That's why option D is wrong. Okay, perfecto. Let's go to the next question. There is a soap bubble of some radius small r which has some potential V. The bubble expands to a new radius. The medium has a permittivity epsilon. Bubble surface tension is sigma, and derive the equilibrium condition relating the potential to all the other variables. This is a wonderful question. Lot of chances of silly mistakes and a bigger chance of not even remembering the formula. Okay, concentrate Naveen. Yeah. Okay, marking attendance, great, very good, awesome. So let's see, how do we do this question? The first step in this question is to concentrate only on the smaller bubble first. Let's not worry about the big bubble. For now, let's look at the small bubble. Okay, that bubble has some radius r, potential V. When the bubble grows in size, will the potential remain constant or the charge remain constant? Answer it in the chat box right away, right now. What do you think will happen? The bubble is blown, so it increases its size for some reason, maybe outside pressure change, God knows, whatever happened. So in this process, what will remain constant? Whether it will be the potential, whether it will be the energy, whether it will be the charge, what volume, what is going to remain constant, guys? Yes, it is the charge which will remain constant. Why? Because charge has no other way to go. Where will it go? Where will it come from? So if charge remains conserved, it's the potential which might change. So this value of potential given to me right now is the original potential. That's the first thing I realize. Maybe I'll first calculate how much charge is there on that bubble, because I might need that charge for further calculations. Yes. Okay. So let's assume that the charge is basically Q. So the potential V is nothing but given by KQ divided by R. This is going to behave like a shell. That is the potential for it. Now, therefore, my charge Q will be V R divided by V into R divided by Coulomb's constant. But I know what is my Coulomb's constant. It is nothing but 1 by 4 pi epsilon naught. I will write it in terms of epsilon because epsilon is mentioned. So, I will not use Coulomb's constant. So that will become VR 4 pi epsilon. That is basically the charge, and it remains constant. It remains conserved. It remains conserved during the process of small r to capital R. But potential will not. But this value which you have taken is the older potential. So it's fine. Now I know the charge. Now let's think about other things. Now after some time, this bubble has grown in size and now it has become basically of radius capital R. Now comes the real thing. What are we supposed to do? Okay, the bubble grows, it has become something else. So what has surface tension got to do with anything? Because we have given surface tension. So we have to think about fluids. Yes, properties of liquids. Remember, the surface tension will try to contract the bubble surface. So the bubble will try to reduce its size, not increase. So there is something which is preventing it from reducing its size, and that is nothing but the excess pressure. So yes, there is then excess pressure inside because of which it is able to sustain that surface tension's force. Now think like this. Earlier that bubble was very happy. Now that bubble had no reason to expand. If and only if there is some external driving force or something which has compelled it to expand, it will not expand. You take a bubble, unless the atmospheric conditions change, you blow in air, something changes, only then it will expand. So in this process of this bubble becoming big, who has led to that expansion? What is the driving force, driving cause? It is the charge given to it, given a potential V. That bubble was very happy. You put some charge, what will those charges do? They will try to repel each other. So because of the repulsion, the size has increased. So this process which has happened over here, this was because of the charge addition. So due to electric repulsion, it has expanded. It has basically expanded. Otherwise, it would have stayed at small r only. Oh, so if electric repulsion is the cause of that expansion, that means the change in the pressure which is there due to the surface tension, that has to be exactly balanced by the excess pressure by the whom? By electrostatic repulsion. So the idea over here is that the excess pressure due to surface tension has to be balanced by the pressure due to electric repulsion. So this is the condition of equilibrium. They have said this word equilibrium is achieved. So inside excess pressure is being balanced by the electric repulsion. Is that now clear? Everyone with me? Okay. So when this happens, only then you're going to see that equilibrium will be achieved. Okay. So let's understand what is the pressure due to the surface tension. It is nothing but 4S divided by R. 4S divided by R. Okay. Electric repulsion, what is the pressure formula? The formula is nothing but charge per unit area, which is the surface charge density, whole square by 2 epsilon. Do you remember this formula? That was what I was telling. You need the formula recollection. So charge per unit area, whole square by 2 epsilon naught. Okay. So my dear warriors, over here, this is 4S by capital R. This is charge per unit area. So this will be nothing but charge square divided by area square, and this will be 1 by 2 epsilon naught. So this will be just 4S by R. Okay. And area is nothing but 4 pi R square. 4 pi R square is the area. So this will be just be 4 pi R square whole square, and this multiplied by 2 epsilon naught. What about the charge? Charge we got it from here. V R 4 pi epsilon. V R 4 pi epsilon. Okay. So we have to take this also and square it. V small r 4 pi epsilon. That's it. Now we just need to keep on solving this. So therefore 4S divided by R will be V square. Then we have R square multiplied by 4 pi epsilon square whole thing divided by, here also we have 4 pi. So 4 pi square, then R raised to 4 multiplied by 2 epsilon. Okay. So couple of things will get cancelled. Like I can see 4 pi square, this 4 pi square, one of the epsilon will get cancelled, one of the epsilon will remain over here. This R will get cancelled, this will become 3. Okay. So what will happen, guys? I will have 4S is equal to V square small r square epsilon whole thing divided by, what else is there? 2 is there and R cube is there. Okay. So we just have to rearrange this. We want V square, right? So let's write down V square. How much will it be? So V square will be 4S into 2R cube. 4S multiplied by 2R cube whole thing divided by small r square epsilon. Small r square epsilon. Till this point absolutely clear? Yes. Perfect. S is surface tension. I think we had to use sigma. I will change it later on. So you can use sigma or S. You can use sigma or S. I've just used S, not an issue. Okay, so where are we? Where are we? Where are we? Yes, so therefore V will be equal to root of this entire thing. 4 into 2 is nothing but 8 S R cube divided by R square epsilon, or you can also write it as 8 sigma R cube divided by R square epsilon. Yes, you can use the symbol sigma also. So 8 sigma R cube by R square epsilon is the answer. Yes, 8 sigma R cube by epsilon R square is V square. So V is the root of it. Perfect. This is how we can solve it. So the idea was that you should remember the formula of pressure due to the electric charges. So the electrostatic pressure is, remember, having the formula of charge square by 2 epsilon naught. So that is being balanced by, you know, the excess pressure due to the surface tension. Okay, perfect. Let's go to the next question on your screen. This was 2019 question and a very nice question. Multiple correct might be there. Okay, read the question, everyone. Yep. Yeah, sigma S, whatever you want to call it. Okay. Yeah. A conducting wire is there. You can see it is in the shape of a parabola. Y is equal to x square. So if x coordinate is root L, so root L square will be L. So that will be the y coordinate at the end point. So this wire is a curved wire. It is moving towards the right side with some velocity of V naught. I cap means right side. In a non-uniform field, you can see the magnetic field has some variation with y coordinate and it is directed towards you because it is k cap. So the magnetic field is directed like this, but it changes only with the y coordinate, not with the x coordinate, which means everywhere here the magnetic field will be same, everywhere here the field will be same, here it will be same, here it will be same, here it will be same, but this variation will be there. So there will be a layer of magnetic field here, then different layer, then different layer. So the field concentration only is different. Think of it like this. Think of it like this, as if the field is somewhat over here. It's k cap, right? So it is towards you actually. So let's say it is like this. Then over here, the field will become slightly different. Then over here, the field will become even more different. As the y coordinate increases, the magnetic field strength also changes. As you can see, here it might be even more. The field might be even more denser. So that is what is happening, guys. Are you able to visualize? Are you able to visualize how this magnetic field is changing with the y coordinate, everyone? Okay, great. Now, if all these things are some positive constants and delta phi is the potential difference between the wire ends, then the correct statements are: for beta is equal to 0, beta is equal to 2, what is the potential difference? Potential difference remains same whether it is replaced by another wire and projected by y-axis. Okay, so couple of concepts involved first of all, even before going ahead. Tell me one thing. If I take a wire like this, whose length is delta x and it moves with some velocity v naught and the magnetic field is towards you. Tell me what will be the EMF generated in that element of wire. Quickly in the chat box, right away, right now, guys. What will be the magnetic field, what will be the EMF developed inside that element? That element is horizontal and moving like this. Remember, if the element's length is in the direction of the velocity and magnetic field is perpendicular, there is no EMF generated, zero. Yeah, so there is no EMF at all. So there is no EMF across the ends of the conductor. 0 volts will be generated. So this will be 0 volts. Now let's take a wire whose element is like this. So this is nothing but your delta Y. It is moving like this inside that magnetic field of B naught. Length, velocity and magnetic field, all three are perpendicular. So in such a case, EMF will be generated. In such a case, EMF will be generated across the ends. Yes, EMF will be generated, and it will be magnetic field into that length, which is delta y, into the velocity. So that will be the EMF, BLV. Is that right, everyone? Great. So this means if I take any curved elements, small part, if I take a small element of the curved part, then the magnetic field, then the elements vertical component, elements vertical component is the one causing the EMF and not the element's horizontal component. So delta X is not contributing, whereas delta Y is the one which is contributing. So no matter what the shape is, always the magnetic field is towards you, velocity is always like this. So isn't it clear that no matter what the shape is, the Y components of the elements are contributing in the EMF, not the X components. Yes or no, guys? So from this, I think two options we can easily decide. Can you tell me, guys, which are the two options? I'll make probably a separate video for Tamil Nadu, don't worry. Yeah, dy element only will be the reason for the contribution. Delta phi is proportional to the length of the wire projected on the y-axis. Yep, you can see. Delta y will remain same if the parabolic wire is replaced by straight wire, curved wire, no matter what you do, whatever you replace, as long as those ends are same, guys, your answer will be the same. So 2 and 4, both options are correct. Yeah. So only now calculation is for 1 and 3. So for that, here is the logic. All right. Observe carefully. So in order to find that magnitude of delta phi, which is nothing but motional EMF, it will be nothing but integral of d phi. And what is this d phi? This d phi is the small EMF generated in any small element, and in any small element only the y coordinates will matter. So it will be nothing but integral of magnetic field into the length, which is just dy, only y components will matter of the conductor, into the velocity. That's it. So let's do the integration. Integral of magnetic field is given already, B naught. We have 1 plus again y by L whole thing raised to beta, bracket complete. This is just dy. Velocity is just v naught. So couple of things will come outside like b naught and v naught. Okay. And then we have integral. This is just dy. Plus here we have 1 by L raised to beta integral y raised to beta dy. That's it. See this integral, guys, if you are comfortable. I just expanded the brackets. So 1 into beta into dy into v naught. Yes, 1 into beta into, 1 into b naught into v naught. Yes, into dy. Perfect. This L raised to beta is coming down. Y raised to beta is on the top. Dy is also there. And this v naught and b naught are anyways outside. Okay. This is a perfect integration. What will be the limits of the integration? Y coordinates only. I am going from 0 to L. So the integration limits will be 0 to L. That's it. So see what this will come out. B naught, v naught. This will be just L plus this will be 1 by L raised to b, and this will be L raised to beta plus 1 by beta plus 1. Perfect. So this will be nothing but b naught v naught, L raised to beta plus 1. L raised to beta will get cancelled, only L will remain. So I'll be just left with L plus L divided by, only L will remain. In the downstairs, you will have beta plus 1. Okay. So L can be also taken outside. So it will be b naught v naught L and brackets 1 plus because L is taken outside, 1 plus 1 by beta plus 1. Now this is a generic expression in beta terms for the EMF generated. But if you look at the option says beta is 0 and beta is 2. So let's just substitute those betas and see what do we exactly get. So if I put beta is equal to 0, then delta phi will come out to be, observe, then this delta phi will be B naught V naught L, B naught V naught L, 1 plus 1 by 0 plus 1, 1 by 0 plus 1. So this is nothing but 1, 1 plus 1 is 2, so it will be 2 B naught V naught L, that's the first thing. If beta is equal to 2, then delta phi will be B naught V naught L, 1 plus 1 by, instead of beta we have to put the number 2. So put the number 2 over here. So this will be 1 by 3, 1 by 3 plus 1 is 4 by 3. So 4 by 3 B naught V naught L. Now let's check which of these options will match. When it is 2, is it matching? 4 by 3 B naught V naught L, yes, it is perfectly matching this thing, definitely. When it is 0, it is half B naught V naught L. No guys, this number half shouldn't have come. This is wrong for beta is equal to 0. You can see for beta is equal to 0, it is 2 B naught V naught L, not half. So obviously the third option goes wrong. 1, 2 and 4th options are correct. Yes, 1, 2 and 4th options are absolutely correct, my dear warriors. Perfecto? Nice? Yeah. Yeah man, JEE aspirant, think whatever you want. SRX, correct. Yeah, think money, whatever you want to think man, I will be very happy. You can make a meme also, you can make a video also, you can make a short, you can do whatever you want. Yeah. Please think whatever evil you want to think about the teachers and post it. Okay. Except for all the good work that we do, post everything which is not even true. Okay. I'm so glad, Rockstars. Yeah. Amazing 99.5 percentile. This is really crazy, man. All the best for JEE Advanced for you too. Okay. Time to start with the next question coming up on your screen, and here it is. Oh my god. And by the way, Roorkee loves this inductor or capacitor based questions where the switches are getting closed or open, or you have to find voltage or current in terms of time or as a function of time. So they love this growth decay of RC, LR circuits. They love these kind of questions. So they can combine them if you notice the previous year trends. Okay, that is my expectation. I don't know, I might be wrong, you might not get it also, but let's see how it goes. In this circuit shown, this switch 1 has been closed for quite some time, I guess, and S2 has been open for a long time. Yes, for a long time only. So because this is closed, this is open, so this branch is completely useless. This is the circuit which will be active right now. This battery will power this inductor and resistor via this switch S1. Okay. Now, at some instant, you open S1 and close S2. This is interesting. S1 is opened, S2 is closed simultaneously. So, immediately after that, because you can see time is 0 plus, time is 0 plus, time is 0 plus. If you remember mathematics limits, 0 plus is a number which is more than 0, like the most immediate number. Limit delta t tends to 0, but it is on the positive side. So what they are asking is, just after you open S1 and you close S2 simultaneously, what is the current through the inductor, what is the current through the capacitor, and what is the rate of change of current through the inductor immediately. So they are not asked as a function of time, but just immediately after that. Okay, ready for it? Fine. Let's go step by step, guys. Let's go step by step. First, let's focus completely on the fact that this has been closed and this has been opened for a very long time. So if that is the scenario, this part is completely useless. So this is open, nothing will be there, nothing will be there. So I'm just going to cross it out very boldly so that it stays in your head. Nothing is happening over here. So there is no charge or there is no potential difference. There is no current in this part initially before t less than 0. This is before we are talking about. Okay, this is before anything happened. So whatever has to happen will happen over here. This battery is going to power up this circuit. Current will go like this, it will go like this and like this. So this will be I naught, let's say. So if I ask you what is I naught, well, the inductor is going to be in steady state. Inductor is going to be in steady state. So in a steady state, this inductor behaves like a wire. It behaves like a wire. So what will be the current? I naught. It will be nothing but the total voltage upon the total resistance. In this case, the voltage which is there is 20. There is only one resistance, so that is 10. So that current will be 2 amperes. Is that okay? So current of 2 amperes is right now flowing, but this is not even the answer that we want, because whatever we have done is for before calculation and we need it for the next part. Now comes the actual question which we have to solve. What will happen in all these things just after you open this and close this? So let's understand that aspect now. Okay. See, when I open this and close this, how will it look? This is gone. Okay. This is how it will be and this is how it will be. Okay. So this has been opened, this has been closed. Now this part will become useless because this is disconnected from the circuit. So don't even bother about this element, which is basically the battery and that switch S1. But remember, the inductor was carrying some current before this event happened. And just because you opened some things, it's not like the inductor will immediately change the current in itself. Yes, it will begin to change, but it will not change immediately. It will take some few milliseconds, then after few seconds, then after few seconds, slowly you will start seeing that decay or that growth in the current. So the point is immediately after, the inductor will resist any change immediately as it's a inertial property of the inductor, right? Inductor resists any kind of changes in the current. So therefore, just after you do this event, the current inside the inductor must be the same as before. And how much was the current inside the inductor before? It was basically 2 ampere. Hence, this should be still 2 amperes. Is that okay, guys? Is that okay, my dear warriors? Everyone? Very good. Very good. No, energy is conserved is wrong. Current is conserved. Energy may not be conserved. In fact, in most of these scenarios, you will see energy gets lost in the switching processes. So energy is not conserved. Okay, keep this in mind. All right. Now, let's think, what will this current even do? This current, which was earlier there of 2 amperes, it can't go here. Earlier, that current was going like this in this circuit, but now this has been disconnected. So where will this current go? It has to be going somewhere. So obviously it will go like this. Obviously it will go like this through this switch, and this will be 2 amperes, 2 amperes, 2 amperes. So what's the current which is flowing inside the capacitor? Yep, the current inside the capacitor will be also 2 amperes because of the circuit. The circuit has no other path allowed. So this current has to go somewhere. So it will go inside the capacitor. So the second problem also solved. The current through the inductor 2 amperes, current through the capacitor 2 amperes. So these were actually easy questions. So if it was an MCQ, you would have immediately got it. The main problem happens over here to figure out what is the rate of change of current. Yeah, what is the rate of change of current? So let's understand. Yes, there is no charge, but after few milliseconds, there will be some charge. This current won't be 2 amperes. This energy will not be the same. All those things will happen. So this capacitor still has no charge. It has no voltage difference, just like before. No charge, no voltage difference, just like before. So if it has 0 volts, it has no charge right now, this capacitor. Maybe if I look at this loop and apply Kirchhoff's law, voltage law, I can get what is this rate of change of current. How? Observe carefully. Let me apply Kirchhoff's voltage law. How can I apply it? Let's say I start from here. I go like this and I come back over here. In this part, there is a resistance, so there will be a drop of I into R. Current is nothing but 2, resistance is nothing but 10. Okay. Here, this is an inductor. The voltage difference is obviously L times di by dt. Inductance is 2 Henry into di divided by dt. I go over here, there is nothing. In this part, there is a resistance and a current, I into R. So minus current multiplied by resistance. Here there is no charge, no voltage, nothing. So minus 0. Here also there is nothing, is equal to 0. So this is my Kirchhoff's voltage law across this loop just after it has been closed and this has been opened. So this will be nothing but minus 20 minus 2 di by dt minus 40 is equal to 0. So therefore 2 times di by dt will be 20 plus 40. Okay, perfect. So what will happen? 2 times di by dt, 2 times, this will be not 20 plus 40, minus 20 minus 40, minus 20 minus 40. I've just taken this on this side. So this will be nothing but minus 60. So therefore, di by dt, what will it be, guys? It will be minus 30 amperes per second. This negative sign implies that the current is reducing. It's not increasing, it's reducing. Makes sense because the resistors will eat away the energy. Yeah, the capacitor might get charged little bit, but eventually the current is going to decay. So the current is reducing at 30 amperes per second. So that's our final answer. So let's lock it. Yeah, before the current in the inductor was 2, after also it is 2. In the capacitor it was not there. Suddenly the current will jump to 2 amperes because all the current which was going here will now be bypassed over here. It will shift its path. The current rate of change was 0 before, then it will become minus 30 amperes per second. So yes, all the answers we have got it. Is that right, everyone? Loved this question on transient circuits. No, it is not minus 10, it was minus 30. Be careful. Minus 30. Cool. Shall we do? Yeah, I'm in Bengaluru. Yep, I'm very much in Bengaluru. Okay, this is also a beautiful question. I have seen multiple times. IIT Roorkee loves the questions on putting slabs inside capacitors, arrangement of capacitors, arranging the slabs in different forms, and yeah, these kind of questions IIT Roorkee loves. So maybe they might ask a question on, you know, what could be the capacitance, what will be the change of charge if capacitances are removed, or if these finite number of capacitances, slabs or infinite number of slabs are placed in different forms. So all these kind of questions, they love it. Okay, so let's do this kind of question. Yeah. Yep. Yes, there are some mechanics questions also. I have kept it mixed. So remember, just some time back we solved some question on, if I'm not wrong, fluids also some time back. Yeah. So there are 11 standard questions also. 11 syllabus is also coming. Okay. But I have kept it like unit wise. So once we get into current electricity circuits, we are just doing circuit problems, then thermo, then this. So we are going back. There are thermo questions also coming. Mechanics is also coming. Don't worry. Okay. So we have a parallel plate capacitor. The distance is something, area is A, and the distance between them is filled with n number of slabs, layers, each with a thickness d by n. Okay, kind of makes sense. If the total distance between the plates is d, d divided by n will be the thickness of each slab or layer. But this n is very large. That means imagine there are 10,000 slabs between the plates. Okay, 10,000 slabs. So each slab will be, whatever is the distance between the plates divided by 10,000. That will be the thickness of each slab or layer. Now, if you talk about the any mth layer, let's say 700th slab, the dielectric constant is given by K, 1 plus that 700 divided by 10,000. So m is the layer that you are focusing on, n is the total number of layers, K is some constant, positive constant, and n is a very large number. So what's the total capacitance of this arrangement? It's a beautiful question. Take a deep breath, think about it, okay, and let me just pull up the diagram for it. You can see the yellow ones are the plates. There are thousands and thousands of slabs in between, each very, very small thickness, and we have to now proceed to figure out the net capacitance. Just let me get some water. Okay, let's do this. Now, tell me first thing, if I split them up into small capacitors, each slab is a capacitor. C1, C2, C3, C5, like that, C10,000, C1 lakh, whatever. These capacitors will be in series or in parallel. Answer that in the chat box. So is alpha 1? I don't know. We'll check it out. I don't know. We'll have to solve it. Tell me quickly, guys, what do you think? Are they in series or in parallel? Yes, they are one after the other. Tuck, 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 tuck. So that means they are in series. So once they are in series, what do you do with capacitors? Exact opposite of resistors. So 1 by C1 plus 1 by C2 plus 1 by C3, like that till whatever is the nth capacitor, 1 by C nth or whatever it is, that will give you 1 by C equivalent. Perfect? Okay. So that idea is there in our head. We have to consider it like series. There is no general formula. And number 2, 1 by C equivalent is 1 by C1 plus 1 by C2, like that we have to do. Okay. Let's do that. Sir, when dielectric layers are placed parallel to the plates, they act like capacitors connected in series. Yes, Lewis Hamilton, correct. Yep. Now, let's write it down over here. 1 by C equivalent is, there are multiple such things. So, integral 1 by dc. Now, what is this dc? dc is the capacitance of any one such layer. How much will that be? How much will that be? Well, that will be nothing but epsilon naught into the dielectric constant of the medium of that mth layer, epsilon K A, which is area, divided by D. So that D will go on the top, which is the thickness of that small layer. So that will be basically delta. Check this out if everybody agrees with this statement. If everybody agrees with this statement, whatever is that thickness of that particular slab. Everyone fine till this point? Okay. Very nice. Very nice. Amazing. Amazing. Now, what we will do? If I substitute K over here and everything, the problem is I can't really integrate it because for integration I need dx. I need x, and I can't see that x nor dx in this kind of integration. So obviously we will be stuck if we go ahead. So we need to recalibrate, we need to rethink what is our dx, what is our x, everything. So let's go back a step and think what are these numbers. First of all, if I go to any one particular layer, that could be at some distance of x from the first plate, the thickness could be some dx of that particular layer. Yeah, that thickness could be some dx right over there. Now, if I want to somehow figure out what is this x, what should I tell? Come on, think about it. If I want to know what is this x, what should I tell? Because only then I can get dx and other things. Come on. Every layer has a thickness of d by n. So this was the first layer. Then this was the second layer. Like that, this is the mth layer. So x coordinate will be the thickness of each layer. Multiplied by the number of layers. So what is the thickness of each layer? We just saw it is nothing but d by n. How many layers are there? From here to here, there are m layers. So won't x be equal to d by n into m? Each layer is d by n. So the x coordinate, this total length will be d by n m number of times. N number of times. Very nice. Amazing. Till this point, everybody gets it. Okay, sir. Let me keep this aside. Let me come back over here. By the way, this layer which I am telling, this thickness which I am telling is right now dx. So if I come back over here and start substituting everything, this will be nothing but integration of, this is nothing but my dx, because I have taken some random place and small thickness over here, which is nothing but dx at this particular x, okay, and this is nothing but your epsilon naught. K will be nothing but k into 1 plus m by n, and this thing multiplied by a. Okay, but still there is a problem. The problem is dx is there. You might be wondering, how do I integrate it? Because there is no x in this entire expression, and m is a variable. M will change. So for that, look at this number m by n, and then you will immediately realize that over here, if I shift d below, x by d is actually m by n. So this is the substitution which I might have to do, because the moment I do this m by n conversion into x by d, I have rewritten the expression in terms of x. So taking this over here, so instead of m by n, I will write it as x by d. See what will happen. This will become integral dx divided by, actually few of the things are constants like this, and a. So I'll take epsilon naught, k and a outside the integration. Integral over here dx 1 plus x divided by d. 1 plus x divided by d instead of m by n. Is this perfectly fine? Okay. Furthermore, if I take the LCM and do the math, this will be x plus d. This d will go on the top. So it will become d divided by epsilon naught k multiplied by a, integration of dx whole thing divided by d plus x. Limits of the integration. X will start from 0 and it will go till d. So the limits of the integration are from 0 to d, of course. Now this looks like 1 by a plus bx form, whose integration is nothing but log of a plus bx, the whole thing divided by b. Yeah, this is log integration, nothing else. Yeah, this is a question from 2019. Yep, correct. So this model is very popular with IIT Roorkee, and even before this, many IITs have asked this kind of models. So that's the reason why we are doing it. Otherwise, there are every PYQ which we can solve, but we are focusing on the most important PYQs models, which most likely may come. Okay, so let's see what happens. This will just become d divided by epsilon naught Ka. This will become log of d plus x. X I will put it as a d. Then I will put log of d plus x. X I will put it as 0. So d plus 0. And then I have to subtract the 2. Is that right? That's what the integration with limits will look like. So this will become d by epsilon naught Ka. This is log of 2d minus log of d. So this will be ln 2d divided by d. dd will cancel, which is ln 2. So this is nothing but 1 by c equivalent. So therefore, our c equivalent will become reciprocal of it. It will become epsilon naught Ka divided by d multiplied by ln 2. Now, if you compare this with that, you can clearly see our alpha value is nothing but 1. Just compare this with this. Obviously, the constant which comes outside is nothing but 1. Hence, 1 is the answer. Okay. So, expect these kind of models as well in JEE. Yes, ln 2 is coming. Perfect. Awesome. Oh, this question. I have seen so many people solving this via some weird methods, long methods, and today Captain Shreyas sir is going to blow your mind. Read this question. This is a very, very old IIT question. This has been repeated in multiple ways where they have given some cladding, total internal reflection related things. Sometimes they give you a square figure, sometimes they give you a rod, sometimes they give you a pipe which is cladded with some other refractive index. These models are very popular in JEE Advanced and of course with IIT Roorkee too. Light is entering at some angle from one face of a cylindrical rod of some index. Find the range so that once the light enters, will never ever leave it. We have all learnt about optical fiber networks. So, this is exactly the concept of optical fiber networks, and see how beautifully IIT has framed this. See, when you have an optical fiber, we have no control of the direction of the light. Maybe light might enter like this, and if it enters like this, I want it to be internally reflected. Maybe the light might even enter like this, and even then I want the light to be internally reflected. Maybe the light might just enter at some crazily steep angle like this, and in that case I still want it to be internally reflected. So there is total internal reflection happening independent of the angle of incidence inside that optical fiber. It's a rod like thing. So how do we ensure that this happens every single time? One might think, sir, we will need almost crazy amount of refractive index for it, but the funny part is the answer comes out to be a decent number which is very easily achievable for an optical fiber. So that's our calculation. Now usually what I have seen people do is, yes, you start with the diagram. This is our cylindrical rod, this is the cross section of it, this is the central axis, let's say, and they start by taking a very generalistic approach, saying the light is entering at some random angle, and then it refracts, and then it has to get reflected over here. So they mark this as I, they mark this as R, they mark this as some 90 minus R, they use some laws of triangles, exterior angle, interior angle, Snell's law here, then create some expression, then maximize and minimize it, whatever, and then you get some value of n, and then you mark the answer. It's one very lengthy approach. If you don't believe me, you see most of the solutions on the internet. Okay, you will see it is like that. But Shreyas sir is going to solve this within few steps. Okay. How many of you have seen this question before? Or have seen the solution before, or are seeing the solution now and seeing that it is some crazy thing? Got it? Okay, YK, अभी मैं यहाँ पढ़ा रहा हूँ तो यहीं पर पढ़ लो. Come on, my dear students. How many of you have seen this, or is this the first time you are seeing this kind of question? What can you do to simplify this? We need to figure out the minimum refractive index so that light is trapped inside. I think of it like this. Rather than finding a very generalistic solution and then trying to find the maxima or minima, I would rather focus on the critical situation. Getting my point? I'll repeat. Okay. For maximal grazing incidence, yes, Lewis. Sir, 8th grade question. Who is it? Pakka. But that is only for one surface. Do not forget, Lewis, there are two surfaces here. So that's where the funny part is. If I show any random ray, I will have to take a very general approach to do maxima minima. I will rather think what will be that critical incidence for which no matter what it will get internally reflected. After that, every other ray will get internally reflected. So I start by, observe this, I start by taking, let's say for example, this ray over here. Imagine a ray which is coming at a very small angle, very small angle of incidence. Just observe this, very small angle of incidence. It will get refracted, and when it gets refracted, it will go like this, and it will go somewhere and hit over here, okay, somewhere really far away. And over there, we can show a normal, probably like this. Okay. And after this, it might get internally reflected or it might go out. Okay. This is one small assumption. Like this is the first ray that I have assumed, that coming at a very small angle of incidence. When it goes and hits over there, it will hit this surface at a decently large angle. It will be a very large angle. Keep that in mind. Okay. So this is very large angle. And this is very small incidence. Now let's take the other extreme. Imagine I slowly increase the angle. I keep on increasing the angle. Now the angle is like this. So what will happen now? It will refract and maybe hit over here. And then it will probably get internally reflected. Maybe. I don't know. One thing is clear. As I keep on increasing the angle of incidence, notice what happens over here. This angle becomes smaller. As I increase the angle of incidence, I notice, because I'm increasing it like that over here, this point is shifting here. So if this point is shifting here, this is obviously reducing. Agree or disagree? Everybody is able to visualize this in your mind? Yeah. So when this angle of incidence was very small, it was going and hitting somewhere over there. So the angle at which it was hitting this surface was very large. So the moment I increase this angle, that point is shifting here, because now that ray will be going over here. It will hit somewhere here. So this angle is obviously reducing. Okay. Now let's go to the most extreme step over here. Observe. I keep on increasing and I increase and I almost reach over here 90 degrees. This is the largest, almost a very large angle of incidence. What will happen? The ray will probably go like this and hit somewhere over here. The ray will go somewhere and hit over here. Okay. And I will have to show this normal. What I will see is this is a very small angle. This is a now very small angle. The moment I make it large, yes, this angle will become very small. Now, these are the only three rays required for me to analyze the entire situation. think for which of these rays, pink, blue or orange, will you solve the entire problem? It should be such that if I solve it for that ray and if I ensure that ray is getting internally reflected, I know for guarantee, for surety, that all other rays will also get internally reflected. Which is that ray that you will be solving? Which is that ray which you will be solving? Will it be that pink, blue or that orange one? If for that ray it gets internally reflected on this surface, 100% sure I am that it will get internally reflected for everything else. How does total internal reflection work? We know that if you are inside a dense medium and the ray is trying to exit into a rare medium and the angle of incidence is bigger than the critical angle, then it gets internally reflected. So if theta more than theta critical, then we notice that it gets totally internally reflected. So think about it. If by chance I am somehow able to see that this ray is getting totally internally reflected, if I am able to see this ray is getting internally reflected, obviously this angle of incidence is more than this angle. So won't this 100% get internally reflected? For sure. This will 100% get internally reflected. Not just that, even this, because this angle is even bigger than that critical angle. So even this will be getting totally internally reflected, guys. So if I solve for this, all other cases get solved. So I can say this is the most critical case for the minimum refractive index. Yes or no, everyone? Yeah, the orange one. Very good, Akhil. Very good, Sivakumar. Proud of all of you. No mathematics done till now, by the way. I have not done any mathematics. I'm just visualizing, not even a single equation till now. Okay, so what I will do is, okay, I need another diagram. I don't need this. So I'll just take the most critical case now and I will try to solve it. So in the most critical case, what will happen is your ray will almost come 90 degrees, but when it goes inside, it will go at critical angle. And again over here, if I show normal, it should get totally internally reflected. It's not yet 90 degrees, it's almost becoming 90. So it will come out of this surface grazing like that. After this, it should get internally reflected. So I'm taking that limiting condition. So I can say that my angle of incidence is nearing 90 degrees and this angle is also tending towards, I can say, 90 degrees. If that's the scenario, can you guess what this angle and what this angle should be? Obviously, this should be the critical angle and this should be also the critical angle. Yes or no, everyone? Yes or no, everyone? Both of them should be the critical angle? Very nice. No need of Snell's law, man. Wait, right now. Now, we know that this is 90 degrees. We know this is 90 degrees. So, can you guess what theta c will be? Can you guess what theta c will be? Because it's an isosceles triangle. So, it's an isosceles right-angled triangle. Isosceles right-angled triangle. So, what will happen? Theta c will be basically 45 degrees. Theta c will be basically 45 degrees. Yes or no? Very good. Next step. What is sine of theta c? It will be 1 by the refractive index. So sine of 45 is 1 by n. So 1 by root 2 is 1 by n. So n is root 2. So the n minimum value is basically root 2. So in general, n should be more than root 2, 1.4. 1.4 is a decent refractive index, achievable. It's that small, that's all. So any refractive index more than root 2 will ensure that even the most extreme ray is getting internally reflected. So these other rays never even had a chance because their angles were even larger. So they must get internally reflected. So that's it. Within how many basic lines I have got the answer, and you see the solutions online or even somewhere else, they are ridiculous. Got it, everyone? Perfecto. Shall we go ahead to the next question coming up on your screen now? Okay, perfect. Let's go. So the answer was n more than equal to root 2. Perfect. Now this was a question in 2008 by Roorkee, and I feel that this is a good mechanics collision impulse related question. So I think we should do it because again, they generally ask questions on this collisions. There was one more question on collisions in 2019, if you notice, by IIT Roorkee. Some piston was there, some ball is colliding with that piston multiple times. So that question was also there. So they love collisions, momentum, impulse. So keep that in mind. Here it is. We have a wedge which has two different inclinations. This is 60, this is 30. Lengths, everything are given. You leave a mass, it starts going here, and there is a sharp edge. So it will come down, tuck, and it will go somewhere else. Now the collision is inelastic. Collision is inelastic completely at that point. So in that situation, what might be the velocity of that ball, that particle, immediately after the collision at B? That's the first part. Second part is, if it was completely elastic, then what will be the vertical component of the velocity after striking? Crazy. Okay, so let's get this question out for now. Let's focus only on this question, completely inelastic. Then we'll go to elastic, and then we have to find velocity. Then we have to find vertical component also. A lot of things. Yeah. There are a lot of questions. This is a almost 3-hour class you can expect. Yeah, we are almost closing to 2 hours. So yeah, it's a 3-hour class. You can expect it to be. This is, I can see. Yeah. Oh my God. Oh my God. Oh, couple of questions are there. Okay. So let's see, how do we do this? Let's first focus only on this part. Let's only focus on this part right now. Then we will focus on this part later on. Okay. Right now, we'll not focus on that orange part, we'll just focus on that yellow part. If you notice in that triangle, right over here, this is 60 degrees, this is point B, and this is root 3. How much will this height be? This height, think about it, because that height divided by root 3, would have been tan of 60 degrees. So the height divided by root 3 is root 3, tan 60 is root 3. Therefore, that height is root 3 multiplied by root 3, which is 3. So this is basically 3 meters. This is root 3 meters. Okay, so these dimensions are very important. Now let's focus on that block which is there. That block is right over here. It was at rest. So when that comes over here, before the collision I am talking about, before the collision, that block will definitely have some velocity along the incline. So I will call that velocity as V0. Using energy conservation, all my potential energy will convert into kinetic energy. So the potential energy will be M into G into H, which will be equal to half M V0 square. MM will cancel. G is nothing but 10. Height is nothing but 3 meters. This is half into V0 square. Therefore, V0 square is 2 into 10 multiplied by 3. Therefore, my V0, 2 3s are 6. So this is nothing but root of 60 meters per second. This is the velocity before impact. At B. This is before impact at B. It has just reached B right now. So what exactly happens when you reach B? Let's understand that. Okay. Coming back. Observe carefully. This is my inclined plane. of 60 degrees. This is my inclined plane of 30 degrees. The velocity of that ball just before reaching here was like this. How much was it? It was basically V naught. It was basically V naught, which is root 60 meters per second, Because it is inelastic collision, that means after the collision, the particle should not separate, should not have any relative velocity between the surface and that particle along the normal. It should touch that surface and go. I'll repeat. Observe this carefully. If this is my surface, if anything comes and collides inelastically, then after the collision, it will just go like this. This is after perfect inelastic collision. This is how the diagram looks like after the collision. So same thing, it is hitting that surface. So after the collision, it is just going to go that way. So the velocity will be just in this direction. So I will call that velocity as V1. So that means out of V0, two components of velocity, this component of velocity which was in this direction will go off. It will be lost in collision. This will be lost in collision. This will be lost in the inelastic collision. Only this component remains along the surface. This component remains along the surface. Can you guess how much would this angle be? It's not a big deal. Yeah, come on. This is 60, this is 30. How much will that component be, guys? Yep, it is just going to be how much? 30 degrees. From 60 it went to 30, so it has deflected by 30 degrees. So it's obvious now V1 will be V0 cos 30 degrees. So this will be root 60 into cos 30 is root 3 by 2. So this is nothing but 60 multiplied by 3 divided by 4. This is 15 3 is a 45. So 45 meters per second is the velocity after the impact. So whenever you see inelastic collisions, remember the velocity which is in the perpendicular direction to the surface goes off. It sticks to the surface and it continues its momentum in the direction, okay, of the surface. So that is why only this component remains, everything else vanishes. So 45 root should be the answer, and I can see option B is right over here. Everyone? Yeah? Very good. Very good. Very good. Okay. All right. No, it is not option 1. It is option number 2. Option A was before. This was, read the question, immediately afterwards. Now let's think what is the second question. The second question says that if it is completely elastic collision, then what might be the component of the velocity? What might be the component of the velocity in the vertical direction after the collision, after it strikes the second incline? So let's rethink our entire problem now. Okay, so this is our second surface. The first surface is like this. 1 second, I'll just redraw it. 30 degrees is not much. Okay, the first one is at some angle like that, comes and hits it over here. Now, because we are talking about elastic collisions, the property about elastic collisions is that in an elastic collision, the angle of incidence is equal to angle of reflection. So if I have some kind of a surface over here, this is the normal drawn to it, you will see if any particle comes and hits it, it will rebound back like this. This angle will be equal to this angle. That's it. Very simple. The angle of incidence will be equal to angle of reflection. Very simple. So same thing over here. Let me first draw a perpendicular normal to this. This is that normal. Looks like a normal, hopefully. This is the perpendicular drawn to it. Let me also draw the ground horizontal. This is the horizontal. Okay. Now let me start marking the angles one by one. This particular angle is 30 degrees. Then this angle obviously is 60 degrees. This is the direction in which that ball was coming from here, isn't it? That ball was coming from here. Yep. This is obviously the normal drawn to the surface. This is our surface. It is the perpendicular drawn to the surface. The white line is obviously the horizontal. Horizontal. Okay, perfect. Now, if this is 30, this is 60. Okay, it's kind of obvious that this particular angle, observe which angle I am saying. This angle, can you see this angle? How much will this be? This is 60, this is 30. It's obvious that will be also 30 degrees because from 60 you take out 30, 30 will be remaining. Why am I interested in that? Because that will give me the angle of incidence. Observe this angle that you see over here, that is the angle of incidence. So from 90, if this is 30, obviously this is 60 degree, which is the incidence angle. Incidence angles are always measured from the normal. Yes or no? Incidence angles are always measured from the normal. So I will be equal to R for totally elastic collisions. So after the reflection, observe what will happen. It should rebound at 60 degrees. But there is a very funny thing that is happening right now, if you realize. See, if this angle is 30, it's natural that this angle is also 30. So this angle is also going to be 30 degrees. So if this angle is 30 degrees, it's very natural that this angle, because this is perpendicular 90 degrees normal, so this should be 60 degrees, which means after reflection, it has to rebound at 60 degrees. So it will go like this. So this is how it will go after reflection. So this is how it will go after reflection, after the collision, like this. Exactly, it is going along the horizontal direction. So now quickly think and tell me, what is the velocity in the vertical direction? What is the component in the vertical direction? It's going horizontally. There is no component only. So it's a big fat zero. Hence the answer to that particular question is C. Such a beautiful question. Such a beautiful question, guys. And let me see. Yep, it is option C. Perfect. Loved it. Yeah. Such a nice pure geometry. I mean, if you look at it, how many equations did we really write? Over here also, I mean, what was this? This is like finding the component. This was like energy. MGH is half mv square. That's like 9 standard job. Geometry, 9 standard job. Okay. Finding the components. That's all. Here again, finding the components like 11 standard. And this is just again pure geometry and the properties of collision. So if you notice, this question is very conceptual right from the fundamental, but many kids fail in this question because of multiple things. Such a beautiful question. Got it? Loved it, Akhil? Okay. Let's move to the next question. 2019 IIT Roorkee, based out of rotation, moment of inertia, torques, angular momentum, etc. So one of their favorites too, like I mentioned. So if you see previous old IIT papers also, they have asked multiple such questions on that. Okay, so expect a question quite similar to this one. Okay, I'm not saying exactly this one, but rods, moment of inertia, disc, rolling, springs attached or released, what is the angular speed, etc. Those things might be asked. Now they have combined even circular motion in this problem, so that makes it very tricky. And they have also asked normal force, which is again a very tricky thing. So many kids are going to make mistake in it. But even before I go ahead, what is that one trick which I told you during MCQs, and especially with IIT Roorkee, most likely they might give partial marking. Please read the question paper. I'm not saying for sure, but most likely they will give partial marking. read the instruction sheet. If they give partial marking, in a MCQ, always solve the easier options. If you don't have time, leave the difficult options. Out of 4 marks, at least you will get 2 marks. Other options, don't waste your time, because it's not like you will get entire thing correct only when you mark all the options. That's the whole purpose of partial marking. So if I'm assuming A, B, C, D is correct, then if A and B are easy ones, solve A and B, leave C and D for the remaining time. Go to the other question. Do you know this trick, right? Yeah? Okay. Let's do it. Now, there is a rod, length, head vertical, friction, released from rest so that it falls by rotating about the contact point with the floor without slipping. Okay, so it goes like this. Which of the following statements is that correct when the rod makes 60 degrees with the vertical? 60 degrees with the vertical, angular acceleration of the rod, normal force from the floor, radial centripetal acceleration of the center of mass, angular speed, everything literally. Okay, so let's try this out. Crazy. So I think we first need to figure out what is the angular speed, because that will give us literally everything. So, and that will come from torque? No. Angular momentum? No. It will come from energy conservation, because when the rod was vertical, center of mass was high. When the rod comes down slightly like this, the center of mass has lowered itself. So yes, it's the lowering of the center of mass which loses the potential energy, converts it into kinetic energy. Okay, so let's do that. So the center of mass of this particular rod is obviously going to be somewhere over here. And if I draw a horizontal line like this, so, and this angle is obviously 60 degree, this is obviously L by 2. So this will be L by 2 cos 60, cos 60 is half. So this will be L by 4. Earlier, when the rod was here, the center of mass would have been here before, and needless to say, this entire thing would be just L by 2. This is initially. This is initially. Okay. This is where the center of mass would be when it was at rest. It was at rest. Now, when it has come over here, obviously it has some kind of angular speed. Okay. Center of mass has come down. Now, the loss of the center of mass's potential energy is the gain of the kinetic energy. So let's write down that equation. Loss of center of mass potential energy is equal to the gain of kinetic energy of rotation. Gain of kinetic energy of rotation. It is rotating about this point. Yes, this is our point which is not moving because it cannot slide as per the question. It is having large friction. So there is no non-conservative force doing any kind of work. So we can definitely apply conservation of energy principle. So let's do it. Loss of the potential energy, guys. Well, this was L by 2. This is L by 4. So mg L by 2 minus L by 4. That's the difference of the height. Gain of kinetic energy, rotation, half I omega square. I, moment of inertia of the rod. Don't take it as ml square by 12. Common mistake. The rod is not rotating about the center. It is rather rotating at the end. So what's the moment of inertia at the end of the rod? It is ml square by 3. So ml square divided by 3 into omega square. So I feel starting with the energy principle kind of makes sense, because not much of things directly you can get the answer of the angular velocity. Okay, so m will get cancelled, I believe. G will be there. This will become L by 4. This will become L square omega square divided by 6. LL gets cancelled, 2 gets cancelled. So G divided by 2 is L omega square divided by 3. Is that right? 4 divided by 2 is 2, 6 divided by 2 is 3. Okay, so this omega square will become 3G by 2L. Therefore, omega will be root 3G divided by 2L. Root 3G divided by 2L. Yes, no, everyone? This is the first step which we got. Okay, perfect. Awesome. Great. Let's see which of the options are matching now. At least something. Angular speed of the rod. Perfecto. This is absolutely the right answer. Now let's talk about radial and angular accelerations. Let's see if we can get it. How do we get it? Radial acceleration. So if you look at the center of mass of the rod, the center of mass of the rod is at a distance of obviously L by 2. I'm talking about this distance from here to here. This is at a distance of L by 2. This point will have two kinds of accelerations. One will be like this, one will be like this. This will be the centripetal, this will be the tangential acceleration. Is that right? Okay. Perfecto. How much will be the centripetal acceleration? We can find it out. Centripetal acceleration is omega square into r. Omega square, we got it here, 3g by 2l already. So it is 3g divided by 2l. Radius is nothing but L by 2. So just put L by 2 over here. So LL will get cancelled. So it will become 3g by 4 is the radial or centripetal acceleration. This is the radial or centripetal acceleration, 3g by 4. So let's check it out. The radial acceleration will be 3g by 4. Absolutely the right answer. Got it. Now in the exam hall, if I feel that I don't have the mood or the knowledge or the time to solve these two, I will leave this question and jump to the next question, because at least I'll be getting partial marking for these two options. Okay. If I feel that this is lengthy or I cannot do, that's how my mindset would be. I'm training you for exam point of view. Otherwise, we are solving it over here completely. Don't worry. Okay. Now, I feel we might need some tangential acceleration, alpha, everything. For finding tangential acceleration, we obviously need alpha, and to find alpha, oh my god, crazy. Okay, so how do I find angular acceleration, alpha? For alpha, we need torque. For torque, we need forces. And who is that force that will cause that alpha? It is obviously mg, guys. Yeah, mg will cause that torque. Normal will not cause that torque. Normal will be here only. Pavam fellow, it can't cause any torque. Now, how far is mg from that pivot point? Okay, if this is L by 2, that is 60 degrees. If this is L by 2 and this is 60 degrees, it's obvious that this is nothing but 30 degrees, isn't it? This was nothing but 30 degrees. So how far is this pivot point from this mg force? It will be L by 2 cos 30. Cos 30 is root 3 by 2. So this will be root 3 L divided by 4. This is the distance of that pivot point from mg force. So let's apply torque equation. Net torque is equal to I into alpha. The torque is only because of mg. The distance is root 3 L by 4. So put root 3 L by 4 multiplied by mg. Moment of inertia, don't make a mistake, it is ml square by 3, not 12. It's at the end. So ml square by 3 multiplied by alpha. Okay, couple of things getting cancelled. L getting cancelled. So root 3g by 4 is equal to m has gone, L has gone. L alpha by 3. So therefore alpha will be 3 into root 3. So 3 root 3. G is also there. Okay. Divided by L and 4. So 4 times of L. So alpha will be 3 root 3 G by 4L. Alpha will be 3 root 3 G by 4L. Do we have that? Angular acceleration of the rod will be 2G by L. Wrong. This is absolutely wrong, guys. This is wrong. So first option is gone. Everyone? Yeah? Okay. Now, if at all any other option might be correct, it could be the second option. But don't just say, sir, I feel it will be right, so I'll mark it right. Guys, don't do that. Then you will get negative marks. So be careful. If you go with the gut feeling, or if you go with some Tukka strategy in JEE Advanced, you mark this wrong, gone. You will not even get marks for this. Not just forget not getting marks, you will even get negative marks. So read the instructions carefully. There might be partial marking with negative marking in case you make a mistake, because IIT JEE Advanced does not want people to apply any kind of Tukka strategy or some guesswork or some gut feeling. So how do I do the normal reaction part? Now for the normal reaction part, I feel we need to write Newton's law equation, but for that I need the acceleration of the system which is downwards. Because notice one thing over here. if you see mg force is here, normal force is like this, normal force is like this. So this is our mg, this is our normal. Our center of mass is over here, and that center of mass might be having some kind of acceleration vertically, some acceleration horizontally, that's okay. But I'm interested in the vertical acceleration. Only then I can get the normal force. How? Newton's law for a system of particles. It says net force is equal to total mass into acceleration of the center of mass. So the net force is nothing but mg minus n is equal to mass into acceleration of the center of mass, MAV. I am not interested in the horizontal direction, so let's just forget it for now. Even if it is there, I'm not bothered. Okay. So if I have to find n, I need to know AV, because you can see from here n is equal to mg minus m into acceleration in the vertical direction. So how much is that acceleration? That's what we need to figure out. How do we do it? So for that, come back over here. So guys, this is going to be the difficult part. Observe. First find out AT. Don't immediately say, sir, vertical acceleration will be g only. Guys, be careful. How can the vertical acceleration be g? It can't be, because normal is also there. It's not doing free fall motion. So we need to figure out these two accelerations, find out the resultant of them, and just see how much it is in the vertical direction. So a lot of complicated maths is there, substitution is there. So let's do this. So from here we got alpha. So how much will be the tangential acceleration? Alpha into r. Alpha is how much? 3 root 3g by 4l. So 3 root 3g divided by 4l into r. R is nothing but l by 2. Okay, l is there, 2 is there. So this will be 3 root 3g. LL went, 4 2s are 8. So that is your tangential acceleration. Now what do I do from centripetal and tangential? Come back over here. I'll tell you. See, this is our rod, isn't it? This is our rod. Okay. Centripetal is like this. Tangential is like this. We want to find out in the vertical direction. Vertical is like this. Tell me how much is this angle? Tell me how much exactly is this angle? Quickly answer it in the chat box. Because it was clearly mentioned the rod makes an angle of 60 degrees with the vertical. That means this was basically 60 degrees. So the rod with the horizontal, how much is it making? It is making 30 degrees. If this is 30 degrees, can you guess how much is this angle? How much is this angle? Obviously this is 60 degrees. If this is 60, can you guess how much is this angle? This is obviously 30 degrees. That's it. My job is almost done. This is tangential. This is tangential. This is centripetal. If I want how much is vertical acceleration, I will take centripetal's cos 60 component, tangential's cos 30 component, and add them to get the total vertical acceleration. Yes or no? Quickly tell me in the chat box. Why I need vertical acceleration? Because of this, to find normal. So to find only the vertical component of it, this centripetal's component, tangential's component will give me the vertical component. So let's do that. So the acceleration in the vertical direction will be my AC's cos 60 plus AC's cos 60 plus the AT's cos 30. This was geometry. If you are convinced and understood, give me a thumbs up. Yes, Harivasu. Yes, Pandu Champa comes while teaching. Usually, not during JEE Advanced, because JEE Advanced I am completely involved in that problem solving. One thing goes here and there. I think about something else, then I get distracted. Not just students, even teachers. So that's why we need to be very focused when we are solving JEE Advanced. That's the exact level of seriousness every JEE aspirant, advanced aspirant preparing for IIT will have during problem solving. While learning, we have fun. I will be jumping here and there, don't worry. Okay, so let's substitute. What is AC? AC is 3G by 4. Okay, AC is 3G by 4. Cos 60 is half plus 80. It is 3 root 3G by 8. 3 root 3 G by 8. Cos 30 is the root 3 by 2. Okay, let's see what do we get. This will become 3G by 8. 3G by 8 plus this will become 16 root 3 into root 3 3 is a 9, so 9G by 16. Okay, perfect. So 8 2s are 16, so if I take the LCM 16, 3 will become 6, so 6G plus 9G, which is 15G by 16. Perfect. So let's come back over here. Vertical acceleration is 15G by 16. Once I get that, my job is done. Therefore, normal will be mg minus 15 mg by 16 is mg by 16. That's it. Mg by 16 will be the answer. Let's check it out. Oh yes. So this option was the most lengthiest of the option. Do you see how JEE Advanced will trick you, will fool you to solve so many options? But you are smart and you will choose which options to solve. If you go step by step, sir, first I saw option A, then I saw option B, then I saw C, then D. Then first option, to get that you need so many other things. Second option, you get it at the end. So don't go A, B, C, D. You might have to go C, A, D, B, C, D, B, A, whatever. So go as per the process and then mark the options. Sometimes you might have to do the reverse thing. But if you feel that some option is unnecessarily lengthy, leave that question, move on to the next, because at least this much you have solved. Now, whatever you have solved, right, in your rough sheet, make sure you are marking the question number over there properly, because if you want to come back, you should be able to start wherever you left. How many of you have faced this difficulty in rough work? Sir, I came back to the question, but I don't know where I solved that. So again, you have to start from the beginning. Everything you have to do properly. Everything is scrambled up. So be careful when you are doing the rough work also. Let it be not like boards, but at least something which you can understand and not make any silly mistakes. Got it? Very good. Very good. Very good. So brilliant question. Nice. So yeah, B, C, D, A is wrong. That's the right one. Decay constants, nuclear physics, one of the favorites of IIT Roorkee. Let's see this, because if you see 2008, 2019 and even before that, and even the latest IIT trends, the last 4-5 years, nuclear physics has been asked, sometimes decay constant related questions. Yeah, the 2016 rotation question is the OG question. Yep. And even there was one more question which became controversial just 2 years back. The chimney problem of thermodynamics, where Bernoulli's equation, density, whether it is constant or not, that was another crazy question. We just have 2-3 more questions, I feel. Yeah, 1, 2, 3, 4. Oh, 4 questions, guys. We'll do it. We'll do it. The last 3 questions are simple. Yeah, I will send the signature, Louis. I did not get time because I had to make these questions and all of that, right? So my entire day just went. Okay, come on, let's do this. There is a sample, contains some nuclei. It undergoes branching decay into B and C, 2 lambda and lambda. B is also radioactive, decays into another nucleus D with some another constant. Nucleus C is stable. Find the time at which B reaches maximum value expressed in terms of lambda. Wow, brilliant question, guys. It feels very laddu at the beginning, but when you start taking this problem up, then you realize you have taken up a very difficult task. Okay, because I have solved these kind of questions before, and I know it's not so short. It is definitely lengthy and mathematical. Let's understand what is happening over here first. Okay, so we have a nucleus. It is undergoing branching like this. Is undergoing branching like this into B and C. It converts itself into B and C. B is also radioactive and it converts itself into another stable nucleus of D. C anyways is stable, so it does not decay. So A will keep on splitting into B and C. C will remain as it is stable compound, stable daughter, but B will convert itself into D, and that's how the nuclear reaction will proceed until all of A is gone, and eventually you will be only left with D and C, because B will come in for some time, but again that will also decay. Eventually all the B will also convert into D. So initially you will only have A, finally after a very long time you will just be left with C and D. That is the nuclear reaction. Now let's start marking the decay constants. For A to B it is 2 lambda, so this is 2 lambda, this is I think lambda, and this is nothing but lambda by 2. Now the question is, when B reaches maximum value, okay, fine. Now whenever this kind of branching happens, A will keep splitting into parallel paths, so A will have a net effective decay constant. So the effective constant of decay for A, lambda A, will be 2 lambda plus lambda, because they are happening in parallel together. So therefore lambda A is basically 3 lambda. I'm teaching you the steps of solving this kind of question. So anytime this kind of questions come, very likely finding the maximum quantity, when does it happen? So very common probability which might be there of this being asked. Now let's figure out how much is getting decayed, at what rate it is getting decayed, or basically we can say how much is remaining. So let's try to find this out. JEE Advanced paper is really unpredictable. They can give similar models, they can, if they have asked, let's say for example, decay constant maximum time in parallel reactions, they can ask you in just series reaction. That's what I'm saying. So if you know this, you can have some idea at least, rather than starting from zero blank paper. At least you will be starting with some tools in your hand. Okay, same thing, like if you have seen 2-3 times they have asked questions on let's say shells, spheres, charge density, and finding fields and potential. Maybe they'll ask very similar kind, not exactly the same. Yeah, okay, fair enough. So how much quantity of A remains after some time? Originally there was N0, so this is nothing but N0 e to the power effective constant, which is minus 3 lambda into T. This is amount remaining of A, remaining of that particular A. Everybody fine till this point? Okay. Now what do we do? Let's focus our attention on B now. How much of B will be formed? The rate at which B is going to be formed, the rate at which B will be formed is exactly the rate at which A decays into B. The rate at which A decays into B. Think about it. Whatever B will be produced will be coming from A decaying into B. So this rate of decay is the rate at which B will be produced, 100%. So basically the rate at which A decays, dN by dt, what is that formula, guys? What is that formula? Decay constant into the number of nuclei at any given time. So the decay constant, which is nothing but 2 lambda, as you can see, this is 2 lambda into how much ever is remaining at that instant of time. So this is nothing but Na. Everyone fine till this point? Absolutely. Okay, clear? Paka? Cool? Okay. So what is Na? We know Na is nothing but n naught e to the power minus 3 lambda t. So just let's put 2 lambda into n naught into e to the power minus 3 lambda t. So this is the rate at which it has been formed. But do not forget, at the same moment when B is getting formed, some of it will also be getting decayed. So if I ask what is the rate at which B is getting decayed, then it will be the decay constant between B and D into how much ever B is remaining at that moment. Yes or no? How much ever B is remaining into the decay constant. So decay constant is lambda by 2. So this is nothing but lambda by 2 into how much ever B is remaining. Now understand the dynamics, guys. In one place, B is being formed and at the same time B is also decaying. So what is the net rate at which B is being produced? That's very important. It's like somebody is giving you eggs. 100 eggs are coming. But out of those 100 eggs, you are giving 20 eggs to somebody else. So in all, in effect, you are getting 80 eggs you are collecting at your place. Yes or no? So if I ask what is the net rate of B, it will be how much ever you are collecting minus how much ever you are giving away, the subtraction of the two. Are you able to visualize this? Are you able to visualize this? Yeah. JEE Advanced questions are not repetitive. The models are vaguely repetitive, not exactly, vaguely, to get an idea. Because if some teacher has told you, I have leaked the paper, or I will tell you exactly these questions are going to come, they are fooling you. So don't listen like that, okay? You cannot predict JEE Advanced questions to the precise point, but you can get an idea. So that familiarity helps you in the surprise element, and that helps you in the spontaneity, because JEE Advanced is also about spontaneity, meaning at that moment, are you able to think and recollect what and all things can be applied to get the result? So that spontaneity comes only with familiarity. Are you getting my point? Yeah, everyone? Okay, so the net rate at which B will be formed, so dNB by dt is equal to this minus this, so 2 lambda n naught e to the power minus 3 lambda t minus lambda by 2 into NB. Okay, perfect. Now this is a very, very important equation. From this only we get everything. This was what I wanted, because only while solving this I will get when will B become maximum. That's the question, if you notice. The question is exactly that. When will B reach its maximum value? Now, see, if I want to find when will B reach its maximum value, I will give a very simple laddu example, guys. Look at it. First, I am getting, let's say, 100 eggs. I'm getting 100 eggs from one person. I barely had 1 or 2 eggs with me. So maybe I am giving to the next person 1 egg per second or something. Now, after some time, what happens? I am not getting 100 eggs, I am getting 90 eggs. By that time, I have accumulated few eggs. So I am giving some maybe 5 eggs to the next person. Time progresses. I am getting 70 eggs from some hen or something, and to some other person I am giving, let's say, 20 eggs. Now this process continues, and let's say now we are reaching, I'm getting 45 eggs over here, and I am giving over here, let's say, 35 eggs to the next person. And eventually what happens? I get 40 eggs from here and I give 40 eggs to the next person, and then it reverses. This becomes 35 and this becomes this becomes, let's say, 42. Now in this entire journey, can you predict when will I have maximum eggs with me? When will I have the collection of eggs to be maximum? Answer it in the chat box. Out of all these scenarios, spam the answer, guys. It's very visual, very easy to understand this example. Only then we can go to the problem. If I'm getting more but giving less, I'm still collecting more eggs. So in all these places, I'm still collecting. I'm collecting more. Here also I'm collecting. Here also I'm collecting. Here also I'm collecting. But here I am giving more than what I am getting. I'm giving more because you can see this is more than this. So there comes a point when whatever I'm getting is equal to whatever I'm giving. That's it. So till here I was getting. Now I'm giving more effectively. So this is the point where it would be maximum. Yep, 40 equal to 40. Understood this concept, everyone? Now the same thing is happening here also. A is converting to B, B is converting to D. So what happens is there comes a moment when how much ever A is converting to B, exactly that much B is converting to D. That's that moment when B has reached its maximum value. So I can say for sure, that when maximum of B is there, then this number will be 0, dNB by dt will be 0, this number will be 0, dNB by dt will be 0, or whatever I am getting is equal to whatever I am giving, so this number will be equal to this. So I can just say whatever is being formed is equal to whatever has been decayed. So let's start writing these numbers. What is it? 2 lambda n naught. Okay. 2 lambda n naught into e to the power minus 3 lambda t into e to the power minus 3 lambda t. Okay. So I'll just put this over here, and decay is lambda by 2 into nb. Lambda by 2 into nb. Okay, into nb. Lambda cancels, 2 2s are 4. So what I get is nb is equal to lambda cancels, 2 2s are 4. 4 times of n naught e to the power minus 3 lambda t. That's it. This is what I get. Now you will be like, sir, isn't it done? No. Why is it not done? I want to find the time. So sir, it's so simple. Just take the logarithm on both sides and you will get the answer for time. But that's the whole catch, and that's why I said this question is very lengthy, because I do not know what NB is at that moment when time is maximum. Oh my god, this is crazy now. Okay, so how do I get that? So I will have to integrate this to find what NB is as a function of time. Do you understand it? Now at this moment, I know the next step only can give me the answer, but the problem is I do not know what this dude is. NB, number of B atoms, nuclei, how much it is. So to get that, I have to go back and integrate this somehow to get the answer of NB as a function of time. Crazy. Okay, so let's get back to our equation and see what can we do. Okay, so we want this equation. I will take this exact equation and write it over here. dNB by dt is equal to 2 lambda n naught e raised to minus lambda t. I'll do one thing, I'll take this guy over here. So plus lambda by 2 into nb plus lambda by 2 into NB is equal to 2 lambda n naught into e to the power minus 3 lambda t. 2 lambda n naught into e to the power minus 3 lambda t. This I have got it from previous boxed thing. Whatever I had boxed, I have got it from there. Okay. Fair enough till this point. Now, why I did this? Because I want NB on the same side, and then I see maybe I can do something about it. Now, there is a very peculiar type of integration that you have to do, and this is something which is you might have to remember now, because it generally will not strike at that moment unless you are very, very good with derivatives and integration. So that is the only catch over here. That is the only catch over here. So what to do over here is that try to find something whose derivative is both of them. And when there is a plus, and when I differentiate and I am getting a plus, it's most likely that it has to be UV rule. Remember, UV's derivative is UV dash plus VU dash. Why I am doing that? Understand that concept. Because over here, I don't have anything of NB, anything of time except for this one. I don't have dt. So if I get some derivative term over here, I can take the dt and integrate this very easily, and I can only be left with dnb somehow. So right now it is in a non-integrable form. So that's the reason why I'm doing all this business. Try to think of a function whose derivative can give these both terms. So let's see. If I multiply, okay, if I'm getting lambda by 2 here, if I'm not getting here, then maybe lambda by 2 is the derivative of something, and that is not over here. So what if I write dnb by dt into e to the power lambda t by 2, e to the power lambda t by 2. Why am I writing this? Why am I writing this? Why am I writing this? Because e raised to lambda by 2 into times the derivative is this number, and that lambda by 2 will come outside. Okay, just vaguely understand it, then you will understand the next step immediately. Plus I will again write down lambda by 2. I'm just multiplying it with the same number, e raised to lambda t by 2 into basically nb is equal to, because I have multiplied here with this number, I have to multiply it with the same number. So 2 lambda n naught e to the power minus 3 lambda t into e raised to lambda t divided by 2. Okay, I've just multiplied both the sides with this number. Why I did that is because I know when I take this guy's derivative, e raised to x's derivative is e raised to x, but e raised to ax's derivative is e raised to x into a. So that is the reason why I did it. Now, the moment I write it like this, observe what happens, the magic which it happens. This is a function into second function's derivative plus second function into first function's derivative, guys. Notice, this is nothing but dnb by dt into e raised to lambda t by 2 plus this is just nb into derivative of e raised to lambda t by 2. How many of you are able to see this now? Is equal to this entire thing, which is 2 lambda n naught minus 3 lambda t plus half is minus 2.5. 2.5 is pi by 2. So e raised to minus 5 lambda t divided by 2. How many of you saw this step now? This derivative is exactly this. Now this is u v dash plus vu dash. So we can just combine it into one single term, and I can say this is d by dt of nb into e to the power lambda t by 2. This whole thing, uv's derivative is v dash u plus uv dash is equal to 2 lambda n naught e to the power minus 5 lambda t divided by 2. Got it till this point? Yeah, UV rule. Yes, this is a time consuming problem, but this has been kind of asked, by the way. Yeah, not much simpler, a decently simpler, but with the same steps has been asked. So that's the reason why I am doing this just for you guys. Okay, cool. 2027 J aspirant, I love all of your classes. Thank you so much, and the question selections too. This is the all India rank 1 question. Yes, not all India rank 1, even all India rank within 100, I think would solve this for sure. Okay, what next, guys? Okay, but I feel you will have fun solving this. Are you not seeing the fun in the question, the derivative and the integration part? Like that guessing, we had to use UV rule. I'm pretty sure it is the fun part of this entire question. Okay, what do I do now? You can see dt can be taken other side and integrate both of them. Yeah, that's all. So this will be nothing but d of whatever this is, nb e to the power nb. I cannot misplace any of the variables or else everything will go down. E raised to lambda t by 2 integrate is equal to integrate 2 lambda n naught. Okay, I can put that 2 lambda n naught at least outside. So 2 lambda n naught outside integral. What else is there? E raised to minus 5 lambda t by 2, e raised to minus 5 lambda t by 2, and then dt over here. Yeah, makes sense. I just taken that dt over here. Now it looks integrable to me. That's the whole purpose of doing all these steps. This was the most crucial step of the entire problem. Solve 1 or 2 more questions, because if that question comes and you solve it now, you have done it before. Trust me, you are already ahead, a leap ahead of other students. Okay. Now what? Now what, guys? Yeah. I'm doing indefinite integration. I'm not doing definite. So this will just become nb e to the power lambda t by 2 is equal to 2 lambda n naught. And this guy's derivative, sorry, integration, my bad, is e raised to still minus 5 lambda t, whole thing divided by 2, the whole thing divided by minus 5 lambda by 2 and plus c. Okay, so this will become nb e to the power lambda t by 2 is equal to lambda goes, 2 goes on the top. So minus 4 by 5, lambda has gone, n naught e to the power minus 5 lambda t by 2 plus c. Okay, now comes the crucial step where we figure out the constant of integration. Initially, b would have not been there only. So at t is equal to 0, nb will be 0. So therefore, substituting these things, nb is 0 is equal to minus 4 by 5 n naught e raised to minus 0 plus c. So therefore, take it on the other side, constant of integration will be 4 by 5 n naught. That's all. So once I get constant of integration, I have figured out most of the things. Observe, nb e to the power lambda t divided by 2 is equal to, c is 4 n naught by 5. So 4 n naught by 5 is there. 1 minus, because from that constant, this is 4 n naught by 5. And that minus sign from here, minus e to the power minus 5 lambda t divided by 2. Okay, perfect. I've got it till this point. So bring this over here. So we get nb. So nb will be 4 times n naught into 1 minus e to the power minus 5 lambda t divided by 2, whole thing divided by 5, and this number over here, e raised to lambda t divided by 2. Crazy. We did all of this just to get this dude nb, nothing else, just for this. Now, remember our original thing? We had to just substitute it here somewhere. Yeah, we just have to substitute it here in this, and then we'll get the answer, hopefully. So let's write down now. First, let me write down the LHS. So what is the LHS? LHS is this, NB. 4 n naught by 5. Okay. 4 n naught by 5. 1 minus e raised to, I'm doing it very slowly because I know I can make silly mistakes. Minus 5 lambda t by 2 minus 5 lambda t divided by 2. Okay, the whole thing divided by, and over here e raised to lambda t by 2, e raised to lambda t by 2. Deliberately JEE will ask these kind of questions only for the all India rank 1 maybe, or 10 or 100, but you have to be selective. But in case you are aiming for all India rank 100, then obviously you have to do it. Okay. And by the way, Shreyas sir is not teaching for all India rank 10,000, he is teaching for all India rank 1. So keep that in mind. And I have produced all these top ranks before this, so I have to make sure that some kid someday again repeats the same history. Okay, anyways, doing this back, 4 by 5 not okay, this is done. Just check. Yes, this is done. Is equal to, we are going back, this is NB, is equal to this number 4 N naught e raised to minus 3 lambda t. 4 N naught e raised to minus 3 lambda t. So this is substituting NB value, substituting NB value. Now you just have to solve this, guys. 4 N naught cancelled off. Wow, it looks so easy now, है ना? Okay, this is this. So take it on the other side. Okay, is that so? That's what we will do. Everything fine till here, guys? Just check. Everything fine till here. Sir, I got the answer. What have you got the answer? T is equal to 2 by 5 lambda 6. Okay, I don't know. You might have got the answer, may not have got the answer. I don't know. But yeah, we'll try to solve this question. Yep. Yes, your dada is here only. So let's do this, guys. It's not very difficult also. If I take this on the top, what will this become? E raised to minus lambda t by 2 minus e raised to minus 5 lambda t by 2 minus lambda t by 2 is equal to 4. 4 is not there. 4 is not there. 5 is there. 5, because this number 5 will go over here. E raised to minus 3 lambda t. Okay. So this will become e raised to minus lambda t by 2 minus 5 plus 1 is 6. 6 by 2 is 3. So e raised to minus 3 lambda t is equal to 5 e raised to minus 3 lambda t. Okay. So e raised to minus lambda t by 2 is equal to, this will go here. 1 plus 5 is 6. So 6 into e raised to minus 3 lambda t. Okay. Everybody fine till this point? Just check this out. If you want, take this on the other side also, and just take this on this side. So it will become e raised to 3 lambda t minus lambda t by 2 is equal to 6. Okay, I'm just doing with the flow. I'm not really sure. I could have simplified it a little bit better, I guess, but I just don't know. I'm just doing it with the flow. So 3 minus half is 2.5. 2.5 means 5 by 2. So e raised to 5 lambda t by 2 is equal to 6. Oh my god. Finally, I'm nearing the answer. So guys, what is it? Log of 6 to the base a is 5 lambda t by 2. So therefore, t is equal to 2 ln 6 by 5 lambda. That's the answer. Let's see. Yes, 2 ln 6 by 5 lambda. Yeah, we got it. Lovely, lovely, amazing, crazy question. How many of you loved it? Love from Tamilian living in Mumbai. Oh, Pranav, thank you. Vanakkam. Vanakkam. I feel very good meeting my fellow mates because I was born in Tamil Nadu. Yeah, Salem. Yeah. You got the correct answer, Louis. So, just to do a quick recap, if you want to, we first reviewed the structure of what is exactly happening in this reaction. So, it became a parallel reaction with more series reaction. It's the most complex question you can ever get in JEE Advanced Physics, but which is very likely. It's not like it is impossible. This question can come, by the way. Okay, and it has come in different ways in 2019 and even before that. So, we figured out what is the rate at which A decays and how much is A remaining. From that, we figured out how much is the effective rate of B being formed, because some of it will be getting decayed. This was the most important governing equation, I will say. Then I went to the maxima rule, that when it is maximum, then the decay rate and forming rate will be equal. So I did that. I got one simple equation, but the only problem was to find time I needed this. This caused lot of trouble. So I had to take this governing equation and get it into a beautiful integrable form using UV rule and all of that. And finally, when you get it into that integrable form, you obviously do the integration. I did not put limits because it was easy to find the constant. Okay, put initial constant and you get the value of NB. The moment you get this value of NB, you directly put it back over here in this equation, you substitute it and just proceed with the basic algebra. This is simple. This is not that difficult. Okay, you have to be very careful when doing this. You might make some small silly mistakes and you will get the answer. Okay, great. Last few questions on your screen, 2-3 questions. Yes, it is better to leave this question. That is the smart move. See, understand that. So if you guys have seen my strategy, right? Where did it go? You guys seen my strategy. Shreyas sir had put the strategy. Where is it? Where is Shreyas sir's strategy? Somewhere here. IIT Roorkee secret decoded. Don't have to go behind every single question. Watch the strategy. I have told this 60%, 70% is more than enough to get most of the marks. You will be in top ranks, top 100, 500 ranks. Okay. Spherical symmetrical gravitational system has mass density. This pattern of question is also a favorite of IIT Roorkee. I saw, analyzed all the papers. Once they have asked about gravity like this, then they have asked about some n number of particles are there in gravitational field revolving with same kinetic energy. That's a 2019 question. This is a 2008 question. You can see a lot of similarities. Yeah, here this is graphical. There they have asked, if I'm not wrong, number of particles revolving or something. But concept is very similar, that there is a chunk of mass density and they are, having some field and they are revolving in circles. Very similar concept. Anyways, rho naught is a constant. Test mass can undergo circular motion due to gravitational field. See, same thing. Speed as a function of distance. See, I'll tell you what. To figure out the graph. See, if you are outside, then this thing which is there over here, this behaves, whatever this density could be, it is constant anyways. It is clearly mentioned. This behaves like a planet, and then here, whatever that mass is moving with some velocity at some distance r, it is like a satellite. So use the same satellite formula, guys. Same satellite formula. When r is more than r, you are basically outside. When you are basically outside. So that velocity is given by root gm by small r. So velocity is inversely proportional to root r. That means if you draw the graph when you are outside, it's natural, it will be like this. This is how inversely proportional graph will look like. But that is only after r. Keep that in mind. Now, if you go to the options over here, this seems okay. This is out. This is also out. So automatically A and B options get eliminated. Can you see that? Because this is like that, this is like that, this is flat, wrong, this is also flat, gone. So 100% it can't be A and B. So now let's go inside. So when you are inside of this, so think, this is that mass. When you are inside of it, when you are inside, r less than r. Then when this mass revolves with some velocity, the force of attraction which will give that centripetal acceleration will be g, mass of the planet, mass of the satellite, divided by r cube into r. This is the formula. Remember, inside the gravitational field is proportional to the distance from the center. So that's why proportional to r. And this is m and this is v square divided by r. Look at it, you will see v square is something, r into r is basically r square. So V is directly proportional to R. What it means is that this graph will be a straight line. This graph will be a straight line till R. Yes or no? This graph will be a straight line till R. So going back to the diagrams, there is only one such thing. This is a straight line, but this is flat, not proportional. This is the one which is right. This will be wrong. So option C is the right answer. Option C. Got it? Everyone? Pakka? Okay. Very good, very good, very good, very good. Let's go, let's go, let's go, let's go. This question, 2019 question. Yep, let's try to do this. This is also very nice, beautiful question, guys. But not very lengthy, but I feel can be asked on thermodynamics. So I have just two more questions. This is one and one more. That's it. These are straightforward. There is a current carrying wire, metal rod. Wire provides some power and the metal rod is closed in a container. It is observed that the temperature of this rod changes with time as a function of time. Okay, temperature is given. Then what is the heat capacity? I think the question should have been heat capacity. That is not printed. Find heat capacity. Heat capacity. That question is not printed. Yes. Okay. So the question is to find the heat capacity. Let's try to understand this question. Current is being flown into that wire. So there will be some joules heating. Heat will be produced. Because of that heat, the wire will get heated up. The heat is not being lost anywhere. It is inside only. And because of that, the temperature is changing with this equation. So the question is to figure out what is the heat capacity. Heat capacity is different from specific heat capacity. Okay, that was the question. All right. Ready, everyone? Have you guys smashed the like button? All the people who joined in, new, late. Yeah. Let's do this. Ready? Okay. First of all, if I remember the formula of heat capacity, it was nothing but heat is equal to heat capacity into the change in temperature. Correct? That's all. So, whatever heat is given to that rod or that conductor is nothing but the heat capacity multiplied by the change in temperature. So, if the heat given is dQ, heat capacity is C, change in temperature is dt. Most likely derivatives will be there because some function is involved. Now, if I find the heat flow rate, the heat which is given to it, dQ by dt will be C is a constant, bring it outside, dt by dt. This is the rate at which heat is given. The rate at which heat is given is exactly that power. So, understand that this power is exactly the rate at which the heat is given. So, I'll just replace it with P. That's it. Is equal to P into d by dt of temperature. Now, temperature is already given to me. Temperature is already given to me. It is nothing but T naught 1 plus beta into time whole raised to 1 by 4. So, I just probably have to take the derivative of this, nothing more. I just have to take the derivative of this. That's all. Okay. Let's do this. So, therefore, P is equal to C into T naught will come outside. Derivative of this entire thing, check it out. Derivative of 1 is 0 plus beta is as it is. Derivative of t raised to 1 by 4 is 1 by 4, t raised to minus 3 by 4. That's it. Okay. So, from this, I will get P is equal to T naught, or rather first I'll put C, C multiplied by T naught multiplied by beta into T raised to minus 3 by 4, whole thing divided by the number 4. And I want C. So, C will be 4 times of P, whole thing divided by T naught B, and this thing goes on the up. So, T naught beta. So C will be P into 4, perfect. T naught beta is also there. This will go on the other side and it will become T raised to 3 by 4. Okay. Now this can't be the answer because if you notice the options, none of them are like that. Actually, it is not having time. So we need to get rid of time somehow over there. Something or the other we might have to do. What can we do? Somehow I need T raised to 3 by 4. So I got an idea that T raised to 3 by 4, can I write it as, from here I can see T raised to 1 by 4. I write this as T raised to 1 by 4, the whole thing raised to 3. The whole thing raised to 3. Make sense? So somehow I need to get this. And how do I get that? Look at this equation. Look at this equation. Okay, just look at this equation. We don't need this. So over here, I can expand it and say it is T is equal to T naught plus T naught beta T raised to 1 by 4. So therefore, T naught beta T raised to 1 by 4 is equal to T naught taken on the other side. So T minus T naught. Bring these people over here. So T raised to 1 by 4 is T minus T naught whole thing divided by T naught beta. Great. Take this and substitute it over here. Okay. So what do I get? So now substituting that heat capacity will be 4P by T naught beta, 4P by T naught beta into T raised to 1 by 4. What is T raised to 1 by 4? We got it from here. So substitute that. It is nothing but T minus T naught by T naught beta. Great. This whole thing has been cubed. This whole thing has been cubed. Okay, that's it. So it's now simple. 4P and T minus T naught whole raised to 3. Whole thing divided by T naught cube into T naught is T naught raised to 4. So T naught raised to 4. Beta cube into beta is beta raised to 4. So this will be beta raised to 4. That's it. I think we cannot do much after that. So is there an option like that? Yes, it is. Beta raised to 4, T naught raised to 4, T minus T naught cube, 4P. Perfect. Exactly the same option. Yep. Everyone? Pakka? Done, dusted? Loved it? Okay. Great. Okay. Perfect. Yeah. All right. Now, this question, we'll do one thing. We'll discuss it later on. I would rather give it to you as homework now, and we'll discuss the same question in the next session. Okay, so that way you will keep yourself motivated that okay sir, I have to solve this question and I have to come back, right, because you are going to give the solution in the next class, right? So take this question up. It's a match the following. Take a screenshot of it and you have to match the following. It's not like 1:1. One can go with multiple items also. Okay, take a screenshot of it and solve it and be ready for the next class. If you want me to be there for the next class on Thursday, then quickly like the video and sir, waiting for the next class. That should be the comment. Okay, I'm not showing the answers right now. We'll do that in the next lecture because it's a good question. I don't want to just give it to you as homework. I want to discuss it also, right? Yeah. Okay. Yeah. Tomorrow again, I think maths is there and chemistry is there, followed Tuesday, Wednesday, and then again physics, chemistry, maths, and then probably we'll have a mock test on Monday, next Monday or something, or Tuesday. We'll see. We'll figure it out. Okay. Cool. Yeah. Morning 11 o'clock. That is the time because that's the best time. Evening you will have to revise. You will have to work out things. You will get tense. So that's why we're not keeping evening classes. Plus we also have our batches and all of that. So that's the reason. So we'll meet again in the morning. Okay. Thank you so much. All the best. God bless you all. This was Captain Shreyas signing off. Bye bye. Take care.